Good morning, Kumud Badla ma'am.
Good morning.
Yeah. So you want to share, try sharing your file?
I'll just share. Just give me 1 second.
Yes. You're able to, yeah. Slide is changing. Yeah. Thank you. That's perfect. Ashok, you can do the PPT part. Ashok, are you able to hear me?
Yes. So you want me to move the PPT, right, sir?
Or you can upload from your side.
Okay, fine. I'm doing that, sir. Yeah, I'm uploading, sir. I'm sharing my screen, sir. Sir, can you see my screen?
Yeah.
Actually, that YouTube was also on, so you may be hearing some voices later, sir. Good morning, Mitra sir. Subrata ji, good
Good
morning.
morning. Good morning, Ashok ji.
Do you like to just test the screen, sir, sharing?
1 second.
I can just unshare first and then, yeah, you can try, sir.
1 second. Is it visible?
Yes, it is visible. You can just go into PPT mode and move some slides. Yes. We can see the full screen and also it's moving. Great.
Oh,
Thank you so much.
oh.
Hello, Ashok.
Good morning, sir. Good morning, sir.
Good morning.
We can
Is
see
it
you.
clear?
Yes, the voice is clear, sir.
Okay, thank you. Good morning, sir.
Good morning.
Sir.
Am I visible and audible?
Yes, sir. We are very much visible and clearly audible.
So, is there a lot of sun or what?
Good morning, boss.
Good morning. How are you?
Good, good, good.
कैसी तबीयत है अब?
अब अच्छी है.
अच्छा अच्छा, okay, very nice.
और ठीक ठाक.
हाँ बढ़िया. मुझे लग रहा है थोड़ा लाइट जो है पीछे से ज्यादा आ रही है ना, उसको कम करता हूँ.
हाँ, उसको कम करवाएं. I think we'll have to wait for another 5 minutes.
Yes, sir.
Because today it is relatively early, 10 o'clock.
Yes, sir.
People may be joining. The speakers have joined.
We are waiting for the TSTSI ma'am, Pamela ma'am, and our Joint Secretary Power to join, sir. Vishal.
Okay.
Our Joint Secretary has just joined. Good morning, Vishal Kapoor ji. I'm Sunil Kumar, DDG NTI Print. Are you able to hear us?
He's muted.
Yeah. Vishal Kapoor, Joint Secretary, are you able to hear us?
Good morning, sir. Good morning, Sunil ji. Just give me just 1 second. I
That's
think,
okay.
yeah, okay, right.
Sir, do you have Kiran Kuchi number, sir? Sir was facing some issue.
Okay, I don't have it. Let me check. But anyway, but he has earlier joined in this platform.
Yeah. 94913. Ashok? Sunil, can you hear me?
Yes, sir.
Yes, yes. 94
94913
yes,
98508.
98508. Okay, sir.
Yeah.
I'll just try, sir.
Would Secretary Sir be joining?
Secretary Sir is not joining. Our member services, Mithil Sir is joined. He is already joined.
Right. Okay, perfect. So would we be starting now or?
Yeah, just we are waiting for the DG TSDSI, Madam Pamela Kumar. As soon as she joins, we'll start.
Perfect. Thank you.
Madam has joined. Good morning, Pamela ma'am. Are you able to hear us? Good morning,
Good morning, Pamela ji. Yuka Srivastava this side.
Hello, good morning. Am I audible?
Good morning. Good morning.
Yes, ma'am.
Chalo bhai. Mittal sahab bhi aa gaye. Let us start.
Right, sir. I think we'll start. A very warm good morning from NTI National Telecommunication Institute for Policy Research, Innovation and Training to all those who have logged in today for this webinar on 5G use cases with respect to power sector. We are conducting this webinar jointly with the TSDSI, Telecom Standards Development Society of India, India's own SDO. As all of you must be knowing, TSDSI has been taking Indian innovation in telecom and ICT to the world stage of 3GPP and ITU very successfully ever since its inception in 2014. This is the second in a series of webinars that we have planned, focusing on the use cases of 5G in various verticals. The first one was done in March last month, that is, on agriculture and health. Today we focus on power. We will have our next webinar during the last week of May, probably on manufacturing sector. With this, now I invite our Director General and Head NGI PRIT, Sri UK Srivastava sir, to welcome the dignitaries for the opening inaugural session for this important webinar. Over to you, sir.
Thank you. Thank you very much, Sunil. Thank you.
Audio is not working.
Is my audio clear? Huh?
Yes, sir.
Okay. Thank you very much. Good morning, ladies and gentlemen. At the outset, I extend a very warm welcome to Sri A.K. Mittal, Member Services, Digital Communication Commission, who has kindly agreed to inaugurate this webinar on 5G use cases in power sector. Welcome Mittal Sahab to the event. I also welcome Ms. Pamela Kumar, DGT DSI. As Mr. Sunil Kumar was alluding, this program is being done in collaboration with TSDSI. Most welcome, ma'am. And I also welcome Mr. Vishal Kapoor, JS Minister of Power, who has agreed to speak in this event, in fact, deliver a keynote address. Welcome, Mr. Kapoor. I also welcome the eminent speakers who are joining today. They include Mr. Kiran Kuchi from IT Hyderabad, Mr. Subrata Kumar Mitra, Ericsson, Mr. Amarjit Kumar, India Smart Grid, Ms. Komal Wadhwa, National Smart Grid Mission, and Mr. Sanjeev Rana, Tata Power. Welcome all of you, my friends. And I also welcome the officers of Department of Telecom Headquarters, Department of Telecom Field Units, CDOT, Telecom Engineering Center, Telecom Regulatory Authority of India, Telecom Industry, Academia, etc. Not to miss my colleagues from NTI Prit. Most welcome to you all. As you all know, 5G use cases tend to rely on increased speed and consistency of 5G, as well as the latency reductions it offers. And they promise to disrupt both traditional and digital sectors. And there are a plethora of opportunities for 5G technology over the coming months, years, and decades. According to the results of a study by Accenture, 79% of businesses worldwide believe that 5G will have a significant impact on their organization. And 57% of those believe that it will be revolutionary. As such, the 5G benefits will reach all the sectors. As Mr. Sunil Kumar was telling, we conducted a webinar on health and agriculture sectors on 16th of March. That's last month only. This month we have selected power sector because this is another sector which will be significantly impacted by the penetration of 5G technologies in the country. And it is only for this reason that we have selected this sector for discussion today. I hope that discussions today will be informative and educative to you all. Once again, welcome. Thank you very much. Back to Sunil.
Thank you, sir. So I think Pamela ma'am is having some difficulty in reconnecting. So meanwhile, I think we will invite Vishal Kapoorji, Joint Secretary, Ministry of Power, for his keynote address. And if you are able to lucky to get her back, we will listen to her after that. So over to you, Vishal Kapoorji, Joint Secretary.
Good morning, Shri Ekimutaji, Madam Pamela Kumar, Shri UPS Srivastavaji, other ladies and gentlemen. Am I audible? Am I audible?
No, your audio is extremely bad.
We have to reconnect.
Okay. So I'm just reconnecting to you.
Okay.
I think Kapoor sir may start.
I think Kapoor sir only is talking.
What happened?
Audio is also disturbed. So, Mr. Kapoor, can you reconnect?
Well, am I audible now?
Yes. Please go ahead.
Okay. Good morning, everyone. On behalf of Ministry of Power, I'm delighted to be with you in today's webinar. I would like to extend my sincere gratitude to NTI PRIT for inviting me to this webinar and giving me an opportunity to present my views. Policy support, favorable economics, and technological innovations are expected to drive India's transition to a clean, affordable, and reliable electricity grid. As India moves ahead with such a large-scale penetration of variable renewable energy, it requires the entire power systems to be more evolved.
I can't hear anything. Am I audible?
Ma'am, you are audible, ma'am. Right now we are listening to Vishal Kapoor. So after that, we will.
Am I audible?
Go ahead.
अभी आप उनको बाहर कर दीजिए. Please disconnect her because we are not able to hear and there will be disturbance. We'll talk to her later.
Okay. As India moves ahead with large-scale penetration of renewable energy, it will require the entire power system to be more evolved and balanced to ensure reliability, resilience, flexibility, affordability, and sustainability of the entire system. In this context, the role of real-time data becomes all the more important as it will act as an enabler for implementation of new age technologies such as decentralized power generation, intelligent and self-healing distribution grids, smart metering, and innovative consumer services. To take advantage and develop through an understanding of the of the usage of real-time data, the institutions governing and managing the grid would have to evolve as information technology is enabling access to enormous and increasingly diverse real-time data applications. With enormous real-time data availability, it also becomes important to proactively identify areas of usage of data collected. Power grids are currently interconnected through different types of communication networks. However, as the electricity need grows, increasingly diverse, a more sophisticated, inclusive, and an innovative system is required to interconnect mass equipment and transfer data. So far, limitations of high speed, high bandwidth, and low latency movable communication technologies have posed a significant supply side constraint in developing several technologies, including self-driving cars and moving electricity-based and IoT-enabled equipment. The 5G communication technology has the technical characteristics of ultra-high bandwidth, ultra-low latency, and large-scale connectivity that may play an important role in all the sectors, including the power sector. And in fact, the effect of this technology on the overall economy and the sector will have a cascading downstream effect on the power sector. And the power sector may have to fall back on the 5G technologies themselves to surmount these challenges. 5G technology can become a key metric for energy stakeholders to improve system efficiency, improve customer experience, and adapt to ever-changing business dynamics. There are about 3 or 4 broad-based 360 4 or 5 broad-based applications through which we can enable 5G transformation in the power sector. The first one would be precise load control. The interruptible load of massive distributed power users has to be precisely controlled to enable the interaction between the grid and power sources, as well as the instantaneous balance of power supply and demand. Low latency of less than 50 milliseconds ms provided by 5G technology will be finally breaching the requirements for such applications, which so far have been provided only by fiber connectivity, which itself has its challenges of being a kind of a fixed line communication asset. The second major broad-based area would be protection for the distribution network. Identification of faults in a highly complicated and a complex system with precise location and communicating immediate response by disconnecting the appropriate switches without having implications on the grid imbalances to isolate the faulty distribution network is of utmost importance to provide reliable and safe power supply to the households. Electricity consumption and information collection is another of the major application areas. Near real-time data collection from smart meters, as we are rolling out today, enables automatic electricity consumption, information collection, meter analysis and management. This is one major use case that we are currently witnessing. However, in this case, perhaps we'll have to fall back on 4G technologies, which may be good enough for this kind of a use case. But then that's not the end. Increased presence of intermittent natured renewables in the power sector has already posed significant challenges in grid operations and demand projections, and are increasing the imperatives of higher flexibility in generation. Going forward, we are going to see a world where battery-operated robots will be increasingly present in our manufacturing ecosystems, and IoT-enabled remote devices will also be omnipresent. Today, most of the manufacturing and O&M ecosystem is live real-time on the power lines, and estimation of the electricity demand is fairly easy. However, in the future, as these battery-operated devices increasingly start operating in an offline mode, the premium on accurate prediction of power demand for forecasting will increase. This is precisely for the reason that a battery-operated robo will not be connected online to the electricity network, and there is no real-time consumption of electricity. The consumption of electricity will come when these robos and these equipments, they'll start getting connected with the grid for charging purposes. So electricity sector will have to look beyond mere generation, transmission, and distribution of electricity, and it has to increase its interactions with such IT and IoT enabled devices, which would operate beyond the meter to predict the times when these devices will go live for charging and pose a power demand. Electric vehicles are posing such challenges in the near immediate future, and we would need low latency, highly reliable mobile communication networks to ensure that the information from these kind of equipment working in the economy, in the manufacturing ecosystem is exchanged. The information with these is exchanged with the power grid control networks in real time. 5G mobile connectivity would have a major role to play in this endeavor. The use of 5G technology will also go a long way in collecting new real-time data streams. It has the potential to enable electricity utilities to develop intelligent decision-making capabilities to improve operations, reduce downtime, and better serve their consumers. So in the end, I would not take much time. I would like to request all power sector and telecom sector stakeholders to make the best use of such information exchange platforms so that the country gets ready to ride the wave of a rapid technological development for the benefit of our citizens. I once again thank NTI PRIT for having invited me to this webinar. Thank you very much.
Thank you, Vishal Kapoorji, for your thoughtful keynote address, wherein you have highlighted the real role of communication networks, that too the 5G with its low latency and high throughput capabilities, what kind of a key role it can really play in the power sector. So thank you so much for your keynote address in this regard. So now we are able to get back to Madam Pamela Kumar. So ma'am, over to you for your special address.
Sorry about that little technical glitch. So yeah, I heard some part of Mr. Kapoor's presentation, in which he made a case for how important it is to leverage these new technologies in the power sector. So what I would like to do is share just briefly with you the standards world. Yeah, the view from the standards, telecom standards world with respect to the power sector. And just give me a minute to bring up one slide. Share, screen share, okay. Bring up my PPT here. Okay, is my screen visible?
Yes. Yes,
okay.
yes.
Okay, so quickly we have put together this one slider, just a brief of standards related activities with a TSDSI view. And I want to make a case of how we have a platform, we've done something, we've kind of done some pipe cleaners, and now we are ready to really leverage big time. Make a big impact in standardization, which is imperative to leverage these technologies for the power sector. So the context here is also that National Smart Grid Mission has become a member of TSDSI, and they have been very actively involved in these activities at TSDSI. So in our repository here, as we have worked to understand the use cases and requirements from the power sector, mainly with the active involvement of National Smart Grid Mission, these are some of the key documents that we have here. The Ministry of Power has a guidelines for implementation of Smart Grid Mission, is a document which was released in November 2015. And this contains a lot of the use cases, the way they are seeing smart grid deployment in India. Then there was also another document released by TEC in May 2015, which has been submitted to ITU Study Group 20, M2M enablement in power sector. So at the same time, there was a technical report on the power sector use cases, M2M use cases in power sector, done within TSDSI, and that's available on our website. And parts of that were also contributed here through our membership. So going to the second column, the top two items talk about some of the more recent work that has happened and is available. So an extensive study was done on the NB-IoT feature of 3GPP, which is available in the release 13, 14, 15, and 16. And it talks about, and there is a detailed study, and all the references are there, which show how the requirements from National Smart Grid Mission about smart metering in India for urban, rural, and semi-urban areas has been taken and then mapped into the capabilities of narrowband IoT, and it has been demonstrated that from a ORM perspective, the outages and recovery perspective, it's a lot more reliable, and the performance criteria can be met by using NB-IoT, and they make a case on how this will be the most cost-effective and reliable solution in India. The other document that, the Smart IoT communication is a technical report in TSDSI. This was spearheaded by some innovation work that has happened in IIT Delhi on data pruning for IoT applications. And this work is specifically uses the smart metering as a use case to demonstrate the use of this new feature of data pruning and how that will make it more efficient. So this is an example of trying to bring in innovation from our universities into here. And in the bottom row, you find these two documents. The first one on communication requirements and recommendations for the energy sector is a new study item at NIP that has been introduced. And this is a more comprehensive look at all the requirements, working again with National Smart Grid Mission and looking across various use cases, right? Of as mentioned by Mr. Kapoor just earlier, the entire besides smart metering, all the other applications like distributed generation and all of the entire set of use cases from an India context are being studied here. And this report is in progress. We encourage people from the power sector and the telecom sector involved in applications for power sector to get involved in this study. The other very interesting work that is happening in 3GPP for release 18, which is still not it's in early stages, but a very comprehensive document has been put together, a technical report which puts forward 24 smart grid use cases, again covering all these. There's a lot of emphasis on security aspects, electric vehicle charging stations, distributed generation with these photovoltaic roofs and the rooftops and everything. So essentially what they have taken is they have taken the IEEE and the IEC smart grid reports and studied the various scenarios and distilled from that the various communication requirements for these scenarios, for these smart grid scenarios, and define these use cases and map them to the 5G infrastructure, right? The way they are envisioning. And this report will be the precedence of bringing in changes and innovations into 5G and beyond to use the best available technologies for the power sector. So we encourage you to kind of join these studies and make sure that the innovations happening in India and the requirements in India get suitably captured in this global and as well as the work happening within TSDSI and at 3GPP and beyond. So that's what I had to add to today's discussion.
Thank you so much, ma'am, for highlighting the role of TSDSI and giving your perspective on various aspects of M2M, narrowband IoT, smart IoT, and also telling us about what role innovation can play through 5G in the power sector. So thank you so much, ma'am. Now it is time to listen to A.K. Mittal sir, our member services, DCC, Department of Telecom, for his inaugural address and to declare the webinar open. Over to you, sir.
Thank you very much. Shri UK Srivastaji, DG NTI PRIT, Ms. Pamela Kumar, DG TSD SI, Shri Vishal Kapoor, Joint Secretary, Ministry of Power, ladies and gentlemen. It gives me an immense pleasure to be part of the inaugural ceremony of the webinar on 5G use cases for the power sector, which is being organized by the NTI PRIT. With the wide range of speakers from government and industry, I am sure that there will be discussions on wide-ranging issues related to how to optimally utilize 5G technology for addressing various challenges in the power sector. Friends, in future, most of the electric power scenarios will be built on the energy internet, where the energy is generated and shared anytime and anywhere, just like information, presenting new trends and characteristics. Clean and friendly power generation, combination of multiple distributed clean power sources, integration of energy storage and electric vehicles, etc. Communication technology lays the foundation for digital application in the electricity industry and supports the development of energy internet. Power grids are currently interconnected through different types of communication networks. However, as the electricity needs grow increasingly diverse, a more sophisticated, inclusive, and innovative system is required to interconnect mass equipment and transfer data. The 5G has enabled 3 scenarios like enhanced mobile broadband, which is known as EMBB, ultra reliable low latency communication, URLLC, and massive machine type communication, MMTC. Thereby, 5G can play an important role in the generation, transmission, transformation, distribution, consumption, dispatching, and emergency communication processes in the power systems. They can transform the EPCN, energy, power control, and networks, and comprehensively promote the informatization of the power system. It is estimated that 5G enabled global digitalization revenues for 10 major industries will be $1.3 trillion in 2026, with energy and utilities, water, electricity, gas, etc., accounting for the highest share, 19%, or about $250 billion. 5G networks have much higher throughputs than 4G. With a peak rate of up to 20 Gbps, 5G can satisfy the demand for massive data transmission, such as high definition videos and virtual reality. 5G communication latency is an order of magnitude less than 4G, particularly the air interface latency of about 1 millisecond, thus enabling power differential protection, precise load shedding, and other ultra-low latency applications. The 5G network has higher capacity, enabling the connection of 1 million terminals per square kilometers. For example, smart home applications and using the power of Internet of Things, technology can access massive smart terminals. 5G NB IoT technology reduces energy consumption of sensors or nodes by optimizing communication principles, thus eliminating the need to replace communication device batteries or the need to recharge, which provides a good technical basis for the Internet of Everything. There are 4 major application scenarios for 5G in electricity industry: control services,
Thank you so much, sir, for your highly informative inaugural address, wherein you have told us about the concept of energy internet and also the role of 5G in driving innovation to improve the QoS in the power sector, improving its, making it a robust, reliable network to deliver the services for all of us. So thank you very much, sir, for sparing your time and joining this webinar to encourage us. So thank you so much, sir. I also thank Madam Pamela Kumar for agreeing to jointly conduct this event and also joining and giving us a special address from her side. I also thank our Vishal Kapoorji, Joint Secretary Power, for giving a very insightful lecture in this session, inaugural session. So thank you so much to Vishal Kapoorji. And also I thank our respected Director General, NJ Apparat, Yukesh Srivastava sir, who is a constant source of motivation to all of us always. So thank you one and all. This we come to the conclusion of our inaugural session. And now I hand over the session to our Ashok Kumar, Director, India Apparat, to conduct the further sessions of this webinar.
Thank you, sir. Is my voice audible, sir?
Yes.
Yeah, thank you, sir. So thank you so much. I'm Ashok Kumar, Director Wireless Access here at NTI PRIT. So let us begin our most important part of the webinar, that is hearing from our expert speaker. So before we start, I will just briefly introduce our speakers today. So we have Professor Kiran Kuchi. All of us know that Professor Kiran Kuchi is a Professor Dean IIT Hyderabad. He is also founder of Vixig network. He has actually led India's 5G research and standard development effort at 3GPP and also at TSDSI. We have the other speaker, Reji Kumar Pillai. He gave a message in the morning that because of some emergency, he's not able to join, but he has nominated Mr. Amarjit Kumar, who is CEO of Sarma Technologies. He is an active member of IEEE and also Vice Chair of IEEE 802.154U. He is also convener for the panel developing last mile communication protocol for Smart Infrastructure Committee at Bureau of Indian Standard. He is also founding member of Visun Alliance, and he is also working as India Regional Coordinator for Visun Alliance. Mr. Amarjit will be speaking on behalf of Reji Kumar Pillai, President India Smart Grid Forum. We also have Ms. Kumud Wadhwa from National Smart Grid Mission. Kumud is Senior General Manager there at Smart Grid Mission. Kumud has more than 30 years of cross-domain expertise, particularly in power sector. So we'll have opportunity to hear from us. We have an expert speaker from Ericsson India. All of us know him, Mr. Subrata Mitra, who is head government and industry relation at Ericsson India. He's a senior business executive with experience in government relation, policy advocacy, solution and product sales to enterprises and government organizations. So he's one of our expert speaker today. And we also have Sri Sanjeev Rana, who is head of Group IT Infra and Smart Grid Communication at Tata Power, Delhi Transmission Limited. He has experience, over 9-year experience of deep business, functional, etc. in power sector, and we'll be hearing him. So to start with, may I invite Professor Kiran Kuchi to kindly speak on the topic on NB-IoT for this smart meter and all. So over to you, sir. I'll just disconnect.
Thank you, sir. Can you hear me, sir?
Yes, please.
I'm sharing my. Let's see. I'm sharing my screen.
We can see you, sir. See your screen, sir.
Okay, thank you. I get full screen.
Yeah.
Thank you very much. First of all, thank you for inviting me to give this talk. And it also turns out to be a timely discussion for the kind of work we are doing at IIT Hyderabad. First, I would like to thank Sri UK Srivatsava ji and Sri Vishal Kapoor, Sri A.K. Mittal, Pamela, and Sunil Kumar and Ashok Kumar ji. Thank you very much. I want to share some experiences of our own today on 5G use cases in the power sector. We have done fair bit amount of work in this area. So first, what we will do is that I will let my colleague, Professor Pradeep Yamula, to talk about briefly about the role of communications in smart grid, just a couple of minutes. Then I'll talk about what we are doing with respect to energy meters based on NB-IoT technology for smart metering. We have designed the chip, we have designed a meter, We are doing pilots of NB-IoT in our campus. We just kickstarted that program. And I'll again ask my colleague Pradeep to talk about campus energy monitoring system at IIT Hyderabad. This has been operational for the last 3 or 4 years, I would say. A very interesting kind of work that was done. Now we're in the process of upgrading this to 5G. Okay, so we will use both NB-IoT and other forms of 5G and deploy it in our campus. So, but you can see what kind of results we have already achieved with existing wireless technologies. This is the outline of my presentation. What I would like to say before I start my hand over to my colleague Pradeep is that at the present time, we are focusing on NB-IoT, which is a 5G family of technologies. There is something called massive MTC. Massive MTC of 5G is fulfilled by what is called NB-IoT. So it straddles between 4G and 5G. It is defined in 3GPP as a 4G release 13 and 14. However, ITU has adopted NB-IoT as a 5G family of technologies that meets the IMT 2020 requirement. So you can call it 4G, you can call it 5G, but it's going to be NB-IoT. We'll talk about that. We have not done much on the low latency modems for mission critical use cases such as control in the power domain. But this is something we are closely watching. And if there is a requirement that comes up, we'll be happy to do that. And we're also setting up a 5G network in the campus. Very soon, our own network is going to come up. It's totally indigenous, the whole network. Most of the components will be indigenous. So we'll be able to do a lot of work in the power domain, and you can witness glimpses of it in a moment. So I'll hand over to my colleague Pradeep now, just say a few words on this, and from a smart grid point of view. Thank you.
Yeah. So thank you, Dr. Kiran. Yeah, good morning all. So I just wanted to give, since I come from the power engineering background and Professor Kiran is from the communication background, so naturally we are kind of working together. So this is NIST Smart Grid Interoperability Framework, and many of you may be completely familiar with this. So what I wanted to highlight in this are these various domains in which there is a information exchange going on, as indicated by these lines which are connecting. So everywhere there is a communication, then there is a need for these technologies. So if you want to implement under this distribution system, something like demand response or asset management, such kind of applications, then we need this kind of communication. In any way, like all these points were wonderfully covered already in the inaugural sessions. I was listening to them, and it was they have done a much more good job of giving the overview. So may I request the next slide, please? So this is another view. So this is a view of utility information system. So on the left side, you can see the industrial, commercial, and residential kind of consumers. And as we move from left towards right, we keep going towards the higher levels of this entire smart grid. So the last mile connectivity problem is what is the well-known problem again in this area. So power engineers have been struggling with this, the power system people. So now, traditionally, the existing technologies, I believe that we already extracted maximum from them, including up to 4G. So this is the time to upgrade to 5G, as mentioned. And next slide, please. So in this context, so the domains where 5G has applications right now in this, in fact, the 5G has applications throughout the smart grid, but then this area which I highlighted could be the starting immediate concern. That is, smart substations, distributed energy resources, all these things, and then plug-in electric vehicles or even EVs, DERs and all. And more specifically, next slide, please. So this NB-IoT, which is just now Professor Kiran mentioned, is the one which is again forming a suitable match at this end, that is metering and gateways, and at the customer end, because the area is geographically spread out and there are several connections needed there. So this is just a brief idea. I wanted to place the focus area on a map kind of thing. So I now hand over to Dr. Kiran to continue with the technical part. Yeah.
Thank you. I will talk about NB-IoT and what we are doing in this space. Just to refresh the memory of the audience, as the name stands out, cellular NB-IoT, it is a cellular class of technologies. The modem connects to a cell tower. And narrowband, it's an Internet of Things system, that is sensors or meters connected to internet. And a narrowband refers to the bandwidth being very low, as well as the data rate supported is also fairly low. Essentially, you are exchanging, meter information every once in a while, every few hours, or even once a day, depending on what the use case is. And you are able to place these meters deep underground. The network is designed to give you much more path loss tolerance than even GSM. There is 20 dB more coverage with NB-IoT. So you can put these meters practically underground and yet achieve the connectivity. And the way it is achieved is that NB-IoT is a very narrow band communications. You put all your power on practically a single tone, 15 kilohertz bandwidth, single tone modulation, and you repeat these transmissions very heavily until until the base station receives it. So that's the kind of key principles involved here. But from a large picture point of view, this is a 3GPP family of technology, so it will have a SIM card, it will have all the security associated with it. So how are we tackling this issue of NB-IoT? We have multiple stages. We have designed a chip. It's an integrated chip. The only thing that goes outside this chip is a power amplifier and a SIM card and button battery. In the case of smart meters, essentially power is not a major consideration. It's already powered up. And so we'll have a SIM card and a PA outside this chip that you see here. This was the first tape out that we achieved, quite some time back, and we have done a second tape out of this chip. So we are getting volume production ready, around the end of the year. This is a project sponsored by DOT and subsequently by MIT. And we are taking this to volume production, within the next several months. This chip will be available to drive smart meters, and in fact, we are counting on smart meters, electricity meters being the first large use case for this NB-IoT chip that we have developed. The left-hand side is a cut of this chip inside a deep. The left side is the analog portion, and the right side is the digital portion. I don't want to go through all the details, but the point here is that it has a DSP processor, it has an application processor, the RF is integrated, it has GNSS support additionally. So it's fully tailored for smart meters use case, and we are practically ready to go with this. Okay. Just to showcase, some of the, this is a large board that we have a miniaturized version. You can see the green portion here, the chip put on a eval board, and you can see this 200 kilohertz spectrum. It's a functional chip. We're getting ready for field testing shortly. The second step we have taken is that we have indeed designed a meter to meet the stringent low-cost considerations for the single-phase electricity meters. So this meter has DLMS support, and it supports NB-IoT and as well as other modem functionality. This is something we are also working with a public sector company to take it to volume production. So we have this chip story, and we are working on the meter itself. Have a total solution that's coming from a single source, so that you can deploy this technology without too many glitches. The third part of the story that we are attacking is that we are deploying an NB-IoT in our campus. We are in the process of planning. We want to learn how NB-IoT works in a real network condition. I'm sure there are other deployments ongoing elsewhere. We will do that. We'll be doing that. At the same time, we're also going to test our own chip and technology with the meter in our own campus to understand the intricacies involved in field deployment. That's ongoing. This is what I wanted to say today. We are also watching out for other applications of 5G in power domain. If there are low latency applications, we'll be happy to incorporate them in our own campus network or elsewhere. We are putting up a 5G base station right now. It's kind of our own base station. It's a network. And we'll have the capability to use our entire campus as a test bed to test various use cases from the power domain point of view. That's our plan coming up. I'll request my colleague Pradeep to explain what he has done in the last few years using this campus, IITH campus, as a large-scale test bed, and what are the learnings he has. And I think maybe a year from now or later, we will have the same set of results produced with 5G technology. I think here, a few years ago, he used off-the-shelf wireless technologies available, but we'll have some more 5G learnings subsequently. I'll stop here. Pradeep, you can go take it. Thank you.
The next slide, Professor Kiran. So this is how we started. It's just a block diagram for one particular building. So this is the academic block A in our IIT Hyderabad campus. So in that building, we have these submeters available, and this building became operational since 2015. So then since the meters were available, we using a Raspberry Pi IoT module, RS485 to USB communication we are doing. And here, we used Wi-Fi. That's because it's an academic block and we have readily available Wi-Fi there. So this is actually not the what you call the practical case, but then at least this is like the initial step that we had. So the next slide. So here we are getting data with a latency of 1 minute because that is just only for energy monitoring purpose. This is a panel room in the basement of the building. It's a 7 floors building. So one is the emergency panel room and the other is the normal supply panel room. Next slide, please. So here, as Professor Kiran mentioned, we use the IoT module in the middle and this Wi-Fi dongle that you can see. So this and internally it uses the 4G SIM card for sending the data. So this was like done, as we mentioned, 3-4 years back. But anyway, it is still operational. Next slide, please. So earlier I showed the connectivity to the meter. Now we had to go for an additional hardware to connect to the meter. I'm sorry, can you go to the previous this one? So here what you see as separate individual components will now merge into one single component. So the left side, the meter is separate here and the Raspberry Pi module is separate and the communication device is separate. But all these things can be put together as in a very low power mode. That's what Professor Kiran was working on earlier. So yeah, so next slide, please. So the output can be like this. Again, you may be familiar. So you can have a dashboard display and at each floor, what is the consumption, at each room, what is the consumption we can display and which can be updated in real time. Next slide, please. So this is kind of a heat map of, again, it's for a building application. So on the vertical axis, you find the different floors, ground floor, first floor, second floor, like that. And horizontally, the east and west wings of the building. And it shows in a heat map format what is the energy consumption in that building. So you can see 18% of the power is going to the data center, and also in similar amount, close to 18% is going to the AC, for central AC for the building. So the major consumption, 40% energy is going for the data center and air conditioning. Remaining all others are in the other list. That is what we understand from this. Next slide, please. So we can have a load curve of a building. So usually load curve information, it's difficult to get unless you actually monitor. So this is a 1 week load curve. We can see the weekdays and the daily pattern, weekdays and weekends also we can see. Next slide. So we can get a kind of email alert. So this is actually from the last month, 24th March. And we're getting what is the date, what is the consumption of the day, what is the peak demand, what is the peak time. So at what time the HVAC is on. So like this, we can have a customized report and it can be sent as an automated email alert. This is one more application. So I'm just showing the samples how this can be used. Next one. So these are the various things, data analytics based on building monitoring system, power failures or excessive consumption, all these things can be done, and benchmarking of a building consumption with other buildings. And so again, I believe you are all familiar with this kind of applications. So next slide, please. So after working at a building level, then we thought, why not replicate this at the campus level? So what you're seeing on the screen is the IIT Hyderabad campus. So this yellow line is our border, which covers around 570 acres. So sorry, this data is a little old. Right now we have 3,900 students, not 2,600 students. And our peak load is close to 2.5 megawatt. We already have a 1 megawatt solar plant in-house. So from which we get about 5,000 units per day, and we have about 10 11 kV substations, and our daily consumption is about 30 to 40,000 units. So if we actually see, it is like a small microgrid distribution network of 11 kV. So and it's all spread across a few kilometers lengthwise and widthwise. So this is the ideal case for going for an overall campus monitoring. So just one more, next slide. So at this stage, this is a single line diagram. So the top line is a 33 kV level, that is our incoming. Then we have stepped down to two 11 kV bus bars. And from there is an underground 11 kV cable throughout the campus, going through various load centers such as academic blocks and faculty housing, hostel buildings, and so on. And we can also see on the left side corner a 1 megawatt solar plant. Now the task is to kind of monitor this at minimum at a minute by minute level, and find the power consumption patterns. Next slide, please. So this is one again sample result. So because of this substation level monitoring, we can now find the peak demand and peak time at different months. Yeah. So next slide, please. Yeah, so this is not just working in IIT Hyderabad campus. I work with several other campuses, and in a different level, like depending on the size of the campus, different number of meterings we had to install, and similar kind of real-time monitoring system we have provided. So this just for understanding, I have mentioned this. So I think this is the end slide. Next slide, please. Yeah, so that's it from our side. Yeah.
Okay, thank you, Pradeep. I think we're ready to close this talk. We'll be happy to take any questions. But the summary here is that, we are really interested in this area of wireless connectivity in power domain. And you have seen the substantial work done by my colleague. And we are now upgrading all this to NB-IoT and also other forms of 5G. I'll be happy to discuss, if there are any questions. Thank you.
Yeah, thank you, Professor Kiran, and also thank you, Professor Pradeep, for a wonderful presentation. Rather, the practical aspect of implementation of IoT for the power sector. You talked about distribution of the grid. You had solar power generation, and then you were doing grid distribution using this technology, smart metering. You shown us also power energy monitoring. So all aspect of power sector, in fact, you have implemented in IIT Hyderabad, and also helped other some institutions to implement that. And you are upgrading this infrastructure to next level of communication technology. And you, as Professor said, that you also have a plan to finally upgrade it to a 5G network. So thank you so much for wonderful presentation. And I would request our participants, in case you have any question, so kindly write that question in a chat box, and I would request Professor Kiran and also Professor Pradeep, you can straight away answer in the chat box in the interest of time, so that I can now hand it over to our next speaker. So thank you so much. Our next speaker is Subrata ji from Ericsson India. So Subrata ji, over to you for the next presentation. In the meantime, may I request Professor Kiran to just unshare your slides, sir? Yeah.
Yes, sir.
Thank you, sir, for giving this opportunity. We'll be monitoring the chat.
Yeah. And in case you are here, sir, we would be taking live question at the end in case you are able to be here by the end. Otherwise, you just answer in the chat box, sir.
Sir, I may not be available. I'll answer a few questions and then I will leave. If there are any question, people can email me. My email address.
I'll take care of that, sir. I can.
Thank you, sir.
Directly talk to you on that. Thank you. So over to you, Subrata Kumar Mitra ji.
Thank you, Ashok ji. Good morning. Good morning to everyone. Good to see Professor Kochi here. It's always, for me as someone who personally learns a lot from Professor Kochi's session, whether in public or in DOT, it always, gets you thinking that what next? Because the kind of amazing work that he and his team are doing in IIIT Hyderabad, I think it gives a sheer huge amount of confidence to entrepreneurs, innovators, research and scientists in India, the kind of potential that India has and what India can offer to the global world. And I think I am extremely confident the kind of innovations that are coming out, not just from Professor Kochi's institute, but from many other academia institutes, startups in India. India will make a significant contribution to this entire, new industry 4.0, which is almost unraveling around the world. Okay, so with that, I will start. First, I'd like to, start by thanking Mittal sir, Yukesh Srivastava sir, Sunil sir, and Ashok ji for giving me the opportunity to share with you all on what we are seeing, what is happening on 5G around the world, and what is happening in 5G in the enterprises, and mostly specifically in the power sector. Please, I'll just see if it is. Do let me know if my slide is visible.
Yes, it has come. Yeah.
Okay. So, okay, let me just move to the next slide. So just a brief background, I think as said, I look after the public policy, government and industrial relations for Ericsson in India. Just a brief background on Ericsson. Ericsson is in India since 1903. We are possibly now more than 120, close to 120 years in India. And our journey started with setting up the first switch for the erstwhile, government in India. And then since then, our journey with India continues as India transitioned from various technologies, from wireline to the first 2G network, subsequently 3G and 4G. Ericsson has been invaluable partner in the Indian transition in its communication journey, and we are confident as we are doing trials, 5G trials in many cities in country with different operators. We are confident that when India, and that is we expecting it to be soon this year, when India launches onto 5G, we will be contributing the kind of solutions to massively transform. Now, if I can move to the next slide, just to give a background, because we are typically asked, what is happening around the world. That's a perspective to get, and I think here it very clearly shows the kind of deployment that we alone have done. And I think as per the latest numbers, if it is almost close to 220 odd commercial networks which are on. When we say live networks, what it basically means is that you have a a network which is commercially providing 5G services, and for which a subscriber is actually being billed and he's actually paying for that service. And that's all. And these are all, as speakers before mentioned, these are all 3GPP standard networks around the world. So if you see, it's almost today in all the continents across the world, which is there. And it is both in the non-standalone mode and the standalone mode. Okay, now what is that is interesting, which is happening? We are witnessing increased growth of data traffic on the 5G network. In fact, this is what we have always been predicting, that 5G will see a huge spurt in consumption of data by consumers and of course by the enterprises. But in markets like Korea and others, where the networks are fully operational now, we are seeing a significant increase in the network consumption data. We have also seen now almost in all the continents around the world, the 5G networks are on, the networks rollouts are happening. And the positive part is that we are also seeing it being rolled out in the enterprises, because you see, till 4G, the entire the communication technology was around how telecom will be used primarily by consumers, to a small extent by industries. Of course, you had private LTE, narrowband IoT in the LTE context being used by industry, but the entire premise was that in 5G it will be the industry 4.0, this entire IoT, M2M, will actually, the robotics in manufacturing, this will all actually unravel in this era. And 5G is going to be that underlying horizontal technology which will actually enable across the sectors in an economy. And in that, I think energy sector plays a very crucial role in that. Now if I move into where what we are seeing, the trends, I think speakers before, including Kapoorji from the JS from Ministry of Power mentioned, we are seeing some fundamental shifts which are happening in the energy utility sectors around the world. One is that there is a growing increase of digitization or digitalization, as we say, in the power sector alone. But when we say digitalization, is across the generation, the transmission, and the distribution setup, right up to the consumer level. There's a huge amount of digitalization which is happening, and this is a trend. It is not specific to power sector. It is happening in all other sectors, and power sector cannot remain immune. So power sectors are doing it. And if you, as you understand, in power sectors, you have multiple players who are actually getting this done. Second, there is a growing demand that the power sector, because now you have multiple sources of power generations which are coming in, especially renewables, renewables which are coming in from the consumers are generating power and giving it to the grid. There is a huge, demand from the governments and the power regulator that the grids needs to be resilient, and you need to have a grid. Obviously today everything runs on utility, like we say, telecom network cannot go down. Same goes with the utility network, and that's the reason they are saying that, how do you ensure that this grid continues to remain resilient, it continues to remain secured, because we have seen in the past some cases of cyber attacks on networks, attacks on grid. So there's a huge I'll say requirement on the utility industry as a whole to ensure that this grid remains safe, grid remains reliable, and grid is able to deliver as and when the power consumption is needed. And one thing is very clear: as India's GDP growth, we are almost seeing a growth of 7 to 8% plus, and anticipation this will continue. One thing is very clear: the power consumption will just keep growing. As and more Indians are coming out of poverty, they are consuming more and more consumer devices. People are buying more and more consumer electronics at home. Electrification is reaching the last village. So you'll find more and more the power consumption to happen across. Plus we are also now witnessing this huge positive trend of electric vehicles, both in automotive and both in two-wheelers, four-wheelers. And if you have been following, just yesterday the government announced I think the world's largest EV bus tender, where almost close to 5,700 electric buses buses will be rolled out in a few cities in country, and I think that is one of the largest of its kind anywhere in the world. So that's a positive indication of the kind of demand that is going to come from now this entire section of the transportation industry who were erstwhile dependent on say fossil fuel will now be suddenly shifting to run it through their EVs, and that's how they will be then demanding, depending on power. And that's where again we see where the thinking is, what will be the peak load in some parts of the world. We are saying what will be the peak load when they will be allowed. They'll come. We are looking nations coming out with a strategy that how can you encourage EV users to charge their vehicles at a time when the peak loads are slightly lower, so that you can balance it out. So that's a major transition we are seeing in terms of energy usage. And as you understand, transportation is a major contributor to any economy, and as a sector, when they decide to move from one fuel to another fuel, in this case electricity, even a small percentage transition is a huge change as far as the industry is concerned. Then of course we are looking at this entire pressure on the utility industry, primarily to bring down. There is a significant pressure on the utility industry to bring down the carbon emission norm, the CO2 levels. There is a lot of pressure to increase the renewable source mix into that. And I think so from that perspective, the utility industry is undergoing through a massive transformation. And I strongly believe that this is the transformation in which 5G can play a key role. And where we are seeing that key role, one is very clearly in the critical communication in the energy plants. What we are seeing is that within the electricity plant, I think even it was mentioned, there is a critical requirement for reliable, high-speed, low-latency broadband inside the communication facilities, inside the generation facilities. And this is also in the case of transmission and distribution at the say sub-center distribution centers and all, where there is a demand to give this kind of communication network which is reliable, which is not wired, because then things are keeping moving inside, and at the same time where the quality of service is very high, where there is no scope for chance of failure. And in all this context, a 3GPP standard based, I think 5G is actually coming to address. And I completely agree with the Joint Secretary Sir's point that this was one of those cases where the industry was actually waiting for a technology to come. I completely agree with that, and I think the telecom sector has now with coming up with this 5G, it is now addressing this demand around the world. And you will find that in these critical applications which are happening inside the factory, we are inside the generation facilities in these energy plants. We are not just talking about SCADA systems. We are talking about integrating devices across very simple things like integrating even the vehicles which are moving in those facilities. In some cases, they are even integrating backward with some of the Gencos. They have their captive mines. We are even seeing, they are actually extending their networks right up to the mine, so that you have a complete control on the production and the control. And of course, we are clearly witnessing the impact that can happen due to a geopolitical crisis, shortage of coal, what can impact. So today there is a huge concern that power generating companies want to have some kind of control on the backward availability of the in this case coal, so that they can assure their users in terms of the power supply. Then if you move into the today, what is the status of communication? I think this was also elaborated. What we are seeing today is that there are multiple communication systems which are there in today in any enterprise. And I am thinking utility industry or energy plants are no different. You have the standard Wi-Fi, you have the DECT, you have the Tetra, you have the other systems. And some cases you have LT, private LTs and all. You have the regular communication systems. In some cases you have the LAN. But what is happening is that each one of them them, nothing against them, but they have all evolved over a period of time. And today with and there was a growing requirement in the power industry that we need a system which is more reliable, which has a low latency, which can give us a better quality of service, and at the same time the SLAs can be ensured so that we can ensure we can continue on the digitalization transformation. And one another thing was most of these networks were actually siloed networks. Some system came in, it came with its own communication system and so on. And that's where today 5G is actually helping in the transition of these different legacy communication systems to a common communication system within that energy plant, or within that company, or within that entire enterprise, as they are transitioning from migrating the different systems into that. And please understand, we are not merely talking about migrating the communication system. There are in the back end is all these equipments which are almost transitioning along with that. Now, if you see some of the plant challenges, what we are primarily going about addressing, or what this is what we are hearing, I will be sharing some of the white papers that we have published. I'll be sharing it on the chat, and you will find when you go and search on any of the big consulting firms, their huge focus is on this digital transformation of energy companies, and you will find reduce operational costs and stabilize capital expenditure. That is a very standard, because there is a huge pressure on to ensure that the energy cost does not increase significantly. As you all know, energy cost is an input cost to any activity, to any economic activity, and if your input cost continues to increase in cost, then it will have an inflationary impact on the overall, and the output will obviously be expensive. And if I have to just explain, today India is trying to emerge or transform itself into a large manufacturing destination, not just for India, but trying to itself as a manufacturing hub for the world, as an alternate manufacturing hub for the world. But for that, one of the crucial element is constant availability of power. Constant availability of power at a affordable price for the industry to remain competitive. So there's a huge pressure, and this is one of the reason why you are seeing it is there's a how do I say, what is forcing the energy industry to actually transform. There is a growing concern to improve the worker safety and work environment, and other environment factors there. And then there is at end of the day, there is a limit of how much fund you can give. So there is a huge focus on how do you bring down the total cost of ownership, and at the same time, how do you remove this complexity and make life easy in the energy plant. If I move into how does a digital energy plant would look like, if I now purely look at the needs of it, you're obviously the employee and the personal safety is at the top of it. The entire environmental management is there. Cost reduction, how do I increase efficiency, how do I ensure business continuity? This is, I think, is now almost given. The importance of business continuity has really strengthened over the period of time, especially with the kind of economic impact it has on the larger economy. Then at the network side of it, you will see, these things always existed. Only thing I will say which has gone more into it is primarily the security aspect. Otherwise, high availability, reliability, resilient architecture, or multiple redundancy always existed. But security is what we are seeing is a growing emphasis on how do you secure from a network and a cyber perspective of the digital energy plants of the future. Now, if I may just put, this is just to show that if you take an energy plant, primarily as a generation plant, you will find across that there are use cases which are getting deployed today as we speak, whether it is on the remote monitoring, whether it is using UAVs to do, predictive maintenance or scheduled maintenance activities, whether it is UAV to do peripheral level security management of it, to check on your stocks, inventory and all, primarily to also ensure maintenance of transmission lines once it leaves the plant. So across the purpose of this slide is to show that it is not just in one section of the plant where it is happening, it is across what we are seeing, which is that. Now if I just move, this is what I mentioned, whether it is integrating energy, remote monitoring, asset management, or video security surveillance of that. Drones are being extensively used today inside this large industry, large energy plants, and of course in vehicle and handheld connectivity, because we are also seeing there are huge number of vehicle movements which happen inside any energy generation location, and that you need to connect those vehicles, and how do you connect those employees, and how do you give them a handheld connectivity, reliable solution, so that the workers and the personnel can talk to each other. Now, the moving on to some of the use cases which are actually getting deployed and which is getting rolled out is this remote site inspections in energy plants. You will appreciate, typically energy plants are spread over very large areas. They are sometime in remote areas, and let's say you have to do your regular inspection, or you have to do some surprise inspection, or you get an alert, you want to check. Today the normal process is that you have to send an engineer there and check. But today what we are seeing is that you have this drones, this typically small drones secured completely on their because they have their own secured network. The generating company will have its own secured network, so this drone cannot be taken over by, say, an let's say a unfriendly party from outside the network, but these are secured drones inside, which can actually move around your entire plant, can do your inspection, can take the data, send it back to the central command center, where they could be analyzed and then it could be used. And this is what is happening is that, for example, here it says, conducting an inspection almost requires 6 hours to power down the plant. And when what we are seeing is that a production loss of almost $1 million USD, and by this we are actually bringing it down. And what we are doing is that these drones are all working on a private network inside the plant. These are all 5G enabled. 5G, these drones communicate using 5G technology, and the drones are able to inspect the reactor, the hazardous areas of the plant in real time, and and send secure video transmissions in 4K video stream back to the users. And this is just, for example, let me take, let's say you have a NTPC plant. It is not just NTPC alone who is monitoring. You will have, say, turbines coming in from some company, you will have equipments coming in from X. So what will today happen is that, for example, if you have a turbine, say from BHEL, which is, say, in an NTPC plant, the BHEL engineer sitting in BHEL location can actually use similar drone, or ideally from this drone, do and analyze, have a look at the digital twin of their turbine, take corrective measures and all, sitting remotely. And now these are all integrated. So what typically happens is that now when you add all of this efficiency improvement, it is efficiency improvement at, say, the NTPC level, efficiency improvement at the individual the suppliers of turbines, boilers and others, you add them, other services company, and suddenly this all cascade to a very positive improvement in the efficiency of the overall. And that's the reason, if you see, we are talking about very high savings, whether it is 80% reduction of operator exposure to, say, radiation during inspections, or 83% reduction in time to carry out an inspection. And this and if you see the use case, while this is in this context is inside an energy plant, the exact use case is actually being used in a warehouse, where you have large warehouses, whether a particular let's say an SKU is there or not. Typical thing is that you will send someone, he will climb on that ladder or on that forklift, actually the person will go and see and all that, but nothing that today this drone just goes, checks that RFID, checks that barcode scan, and immediately says whether the part is there or not and what location. So the drone use case in this context is just an example to show how it is transforming the basic maintenance activities. The next is actually on the cellular push to video use case, where typically the communication between the personnel is happening, especially, say, between supervisor and the maintenance staff. One use case, one very classic use case is that if they are able to do a good quality video transmission of the actual problem back to that. Similarly, the engineer on the site can actually send the details, the real-time scenario of that equipment back into the vendors or the supply OEMs status. They can fix it. And what we are seeing is that there is almost a 66% reduction in the number of rollouts needed per service call. This is primarily for companies who are servicing and maintaining those setup, and almost 50% reduction in the annual OPEX. What it basically helps is, the energy companies actually to bring down their OPEX costs, it brings down the downtime costs, and all this translates into a increased viability. I will not call it directly profits, because there is a significant pressure on these energy utilities worldwide to keep the prices down. So whatever savings we do actually increase them and make them viable and profitable in the long run. Now, if I move to the last point is what I told about the turbines and generator. These are coming from multiple OEMs into a plant. Sometimes these generators come over different generations. They are supplied, as you know, the different tenders, different winners, different people supply. And what we are seeing is that the number of by deploying this 5G, you are actually bringing down the number of maintenance sessions needed per plant. You're bringing down the loss of income, because you now don't have to shut down your equipment as frequently as it was before. Just one use case, I thought a lot of them are getting deployed, but this is one very public use case. One can go and seek it. This is on the Southern Link in the US, where actually by deploying we have in the advanced capability, whether it's on the grid control, on the automation side, the SCADA monitoring now is much better. And of course, this was done with LTE. Now it's being upgraded onto the will eventually move on to 5G as and when it comes in. And then we have also seen smart lighting, smart parking, as we say, this EV charging and all these are creating the demands, and these are now getting backward integrated to that. With this, I will pause here. I think I'm already running a bit ahead of my time. So thanks for the opportunity. I am available. If you have any questions, feel free to drop in. And after I give the control back to Ashokji, I will share those white papers on the chat. My request is, feel free to read. Those are very interesting white papers to get a perspective on how 5G is going to transform the utility industry, the energy utility industry as we see. Thank you, Ashokji.
Yeah, thank you, Subrata ji, for wonderful presentation. You covered all aspect of technology which can be used in power sector, starting from critical communication in energy plant you talked about. And you also talked about various technology use cases, particularly of communication one for the plants. And also you talked about remote site monitoring, where you talked about how a drone can help and save even a lot of money which goes into shutdown for the maintenance purpose. The new thing which you talked about, push to video. So we have been listening about push to talk till 2G, 3G and 4G technology. Now it's a push to video, which will really become a very, very useful service, not only for energy, but for many, many other sectors. You also talked about how predictive maintenance becomes a use case using the 5G and 4G technology. And you also talked about perhaps mentioned about private networks, right? So thank you so much, Subrata ji. And now may I request our participant, in case you have any question, please write those questions in the chat box. I know that Subrata ji have another session after some time, after perhaps he has 10-15 minutes more to join the next session. So I would request Subrata ji that as far as possible, kindly answer the question which will be coming in the chat box, so that I continue with the next presentation, sir. Thank you so much.
Ashok ji. Yeah, Ashok ji, I'll mail the documents, request you to kindly share with the participants.
Sure.
And I will address the chat question. Thank you again.
Yeah. Thank you. And before I invite next speaker, I want to thank Professor Kuchi and Professor Pradeep, because I saw them answering a whole lot of questions which came into the chat box. So thank you so much, Professor Kuchi and Professor Pradeep. Now, may I request, we are starting the next session, wherein we'll be talking about various disruptive technology in power sector. And next in line, we have Amarjeet Kumar sir. So Amarjeet sir, kindly open your video and mic, please. And over to you. In the meantime, may I request, yes, I can see you, sir. May I request Subrata ji to unshare your, I think, screen, so that, yeah, Amarjeet ji, if you, if you have any presentation, please
Yes.
load that, sir.
Yes. Give me a second.
Sure.
Let me know if you can see my screen.
Yes. Yes, we can see. Can you just go to PPT mode, sir?
Yes, yes, I'll do that.
So by the
Okay.
time Amarjit is like ready with this, in fact, Mr. Reggie was to present, but suddenly he had some emergency and he requested Amarjit, and I'm very, very thankful that very, very short notice Amarjit was able to come for this session. So thank you so much for coming, and over to you.
Yeah, thank you. Thank you for inviting, and thanks, Reggie, to nominating me. Unfortunately, I could not get much time, but I could prepare a very small presentation and try to capture some of the topics which Reggie wanted to cover, and I have added some things from my side as well. So I'll go ahead and start my presentation, and if any questions, definitely I'll be here to answer those questions. So this is what I'm going to talk.
May I, Amarjit ji, it's coming in the other view is also we are able to see like next slide and others.
Okay.
I think, yeah.
Just a second. I will.
You can, yeah.
Is this?
Yeah, this is fine. Sir. The whole screen now is coming.
Okay.
Yeah, thank you.
So I will be talking about primarily on different technologies, what is being used, and what are the different requirements, what we see in terms of the critical infrastructure, primarily as the power sector. And also we will see, I'll talk about some of the ongoing issues and learnings what we have and what we are trying to deal with when we are trying to use other technologies, right? And I will also talk about the 5G, what is my view on that, and what are the different features of 5G, which I think will be critical for or good for the critical infrastructure like power sector, and some of the recommendations. So okay, so whenever we talk about any communication technology, we do see that there are different use cases like AMI, demand response, substation, distribution automation. So there are a lot of variety of use cases are there. And all of the use cases have different requirements in terms of when we talk about the bandwidth, what is required, the kind of latencies which is required for these kind of applications, the reliability and things like that. So there can be some communication technology which can meet any specific use case, but there may be some of the technology which may basically take care of all of those, right? So it really depends on the use case and the technology what you are choosing, which may basically impact on the deployments and rollouts, and it may restrict your use case where you want to use these particular technologies. So it is very important to basically look at the requirement and network requirement in terms of the use case before we select any technology, because that may impact your reliability and the SLAs what you are looking at. So as we know, there are many technologies, there are many communication technologies available across different SDOs. There can be like 15.4 or PLC, Wi-Fi, Ethernet, fiber, cellular, TV white space. So there are tons of communication technologies today available in the market, and people are doing a lot of trials, a lot of deployments. Again, it goes back to the use case where you are trying to deploy that particular technology, and depending on the use case, your network requirement, you will have to basically decide on the technology what you are trying to use. So there are different technologies what we are using. If we look at the wired technology, there are fiber network which is being tried by power grid in past, We have seen people trying with the lease line connections. We see PLC trials also happened in Tripura earlier, where we see some setbacks there. We also see that there are some broadband internet services on power line also that was tried by Reliance Infrastructure. So there are many use cases. There are many in terms of the power infrastructure. What we see here, there are many use cases being tried, tested using different wired communication. When we talk about wireless, we do see people using microwave in here where I located. Bangalore Bescom tried using microwave for their distribution automation by putting long towers. We see satellite communication being used for their power plant remote places. We do see the NB-IoT, LoRaWAN, cellular, the RF mesh. Primarily these NB-IoT, LoRaWAN, cellular, and RF mesh towards the AMI use cases. So there are different technologies we have tried, we have tested. Some we have seen setbacks like PLC. Some we have seen good success. Some we have seen moderate success. Some we have seen success with some low SLAs because of certain reasons. So there are mixed output of different technologies used for different use cases across different use cases what we have in the power sector. So if we talk about the ongoing things, what we see issues based on whatever technology so far we have used. One, the two primary issue what we see is the unlicensed spectrum what we have today. So earlier we had 865 to 867 megahertz. I remember working with TEC and generating a technical report in 2015 with the help of Susil sirs there. So we had a technical report where we spoke about what kind of IoT and requirements we are going to see in near future and far future. Also, it has the coverage of the PLC, what kind of frequency and other things we are looking, because PLC is also something we are looking at can be used for different use cases like broadband and your last mile communication. So there are different communications can be realized using PLC, and we don't have much of a regulation around PLC today. Similarly, in unlicensed spectrum, we had only 2 megahertz. So when we wrote this recommendation from TEC, we had somewhere around, I think, 10 to 15 megahertz spectrum was recommended by TEC. This was sent by TRI, and TRI had sent a recommendation of 7 megahertz. But so far, we have received only one. But when we received, we saw a lot of restrictions also, along with the this additional 1 megahertz, which has its own pros and cons. I would like to highlight some of these issues what we see in terms of this new regulation. I would talk briefly about that as well. So if you look at the new spectrum, new regulation, with one more megahertz spectrum available for us, we see that the transmit power is reduced in some cases from 1 watt to it has reduced to 25 milliwatt, in some cases to 500 milliwatt. So this is good for some of the use cases, but not good for all the use cases. So if you look at any of these star network or tower-based devices where you have all the devices communicating to a single tower, they are bound to have less coverage. And it means that they will have to install more number of DCUs or towers in the system. So it will basically increase your CapEx and OpEx also. So that is something we see that is not very encouraging for the industry, reducing the transmit power. We also see that there are some duty cycle restrictions of like less than 10% kind of a thing has been introduced, where if you have millions of meters trying to do a remote connect disconnect at the same point of time, it is not going to be very effective at that point of time with this kind of regulation. So that is something we need to again relook into it. Channel spacing, we had earlier, we had a channel spacing of 200 kilohertz channel spacing maximum, but the transmit power was 1 watt. Now we see that there are multiple options with 50 kilohertz channel spacing maximum with 25 milliwatt transmit power. We have one with 200 kilohertz with 500 milliwatt. We also see that there is a use case where we have 600 kilohertz with a 25 milliwatt. Now, this channel spacing directly impacts your data rate, what you can operate with, right? So lower the channel spacing, you may not be able to operate with a higher data rate. Now, some of the use case, if you look at the power sector, it demands rather good amount of data rate. Some of them doesn't need that kind of a data rate, but which means that with this kind of regulation, those use cases where you need little higher data rate will be difficult to implement. So our recommendation when we wrote in the TEC technical report, we had requested to increase it to 600 kilohertz. This gives us to increase the data rate that helps cover all the different kinds of use cases. So these are some of the things which we have noted that the new gadget notification what we have received limits the use cases and the deployments further. So these are some of the issues we have noted. Other things, what we see is now since 200 kilohertz has been reduced in some cases to 50 kilohertz, the other standards what we have, whether it is from IEEE 802.15.4, whether it is from IS 18010 and 18010-5-1, in these we have the specification uses 200 kilohertz channel spacing. So then these standards also will have to be reconsidered. And this will be a problem for us in future as an ecosystem. Because our system will not be aligned with the regulation, our standards will not be aligned with the regulation. So that's another implications we see there. We also have some other topics like frequency hopping not considered, which helps us mitigate a lot of issues in real world. Multipath fading and channel agility. So all of these comes which are not considered, which we had these kind of recommendations in our technical report. So these are some of the things which we need to consider. In case of PLC also, we have not yet seen any movement there. So we need to get going there also because there are other new use cases. I remember last week we had a session in IEEE where we wanted to do a surface wave communication over the power line. So there are a lot of things happening, and we are lacking in terms of bringing the right regulation at the right time. Otherwise, we are lacking on those. We are missing basically the innovations happening across the globe in terms of those technology, which we are not able to leverage because we don't have the right regulation in India here. Coming to 5G, these are the three main key things which I feel people may agree, disagree, but this is my personal view that the strong security, ultra reliable, low latency communication, and massive machine type communication. These are the three key things of the features of the 5G communication, which is going to help in any of the critical infrastructure we are going to deploy, whether it is power or any other critical infrastructure we talk about. But in general, what we have seen based on our experience, nothing to do with 5G, it's to do with the way the cellular communication, the cellular services available in India. The biggest problem what we see is in terms of the SLA, where we are not as a system deployment or the ecosystem member or partner and the utility, we are not able to achieve the kind of SLAs what a critical infrastructure need. A critical infrastructure like power utility will have to, SLA is the basic thing. Without SLA, there is no critical infrastructure. If SLAs are not being met, then we may not be able to use that particular technology extensively. So SLAs are very important for any critical infrastructure, including power utility, along with others like security, right? So how do we get the benefit of the 5G, the benefit what 5G brings, while mitigating the issues of SLAs with respect to the telecom service provider or other reasons, right? So there can be like a private 5G network deployed for critical infrastructure where they design their network in a way that it takes care of their SLAs. And obviously, we may need to consider of a separate spectrum for critical infrastructure, where these spectrum can be provided to the power utilities or any other critical infrastructure, so that they can basically deploy their system more reliably and private 5G network, and it can also help us reduce the cost of the system, because if these spectrums are provided to the utility on a lower cost, it basically definitely reduce the as India is a very price sensitive, right? So we also need to consider that if the price of the spectrum is loaded towards these kind of network, then it's going to add to the cost of the system. So if we can consider having a separate spectrum for critical infrastructure, maybe allocating them separately, rolling out a private 5G network for critical infrastructure like power utility and others, will definitely help us utilize the benefits of 5G and mitigating the issues what we see in terms of the SLAs and other issues with respect to the cellular communication. So with this, I have the set of recommendation which we had from ISGF side, like again, delicensing 6 more megahertz spectrum, resuming the transmit power to again 1 watt, channel spacing, increase it to at least 600 so that we can have higher data rate use cases covered there, PLC spectrum licensing. We need to also formulate some policies for offering the broadband service over power, so that once we have the PLC spectrum regulation in place, this power utility can also utilize the same infrastructure to provide the broadband service to the users. So define SLAs for cellular operators, because this is not only with the 5G, this is in general with the cellular operators. We see the issues with respect to the cellular SLAs. So this is something needs to be worked out. Again, we need more and more pilots in terms of the new technologies like 5G, NB-IoT, TV white space, and other things. So this is what I had in my presentation. If any question I can answer, please feel free to put it on the chat box.
Thank you so much, Amarjeet ji, for such a insightful presentation. You talked about spectrum requirement for the critical infrastructure sector. So basically, you also brought out all the implication of the new rule on RF spectrum, which was released earlier, and you have also given your recommendation on that. You talked about the private 5G network spectrum, and it's a new dimension about allocating spectrum for critical infrastructure. So private 5G network, if has to be rolled out for say critical infrastructure like power. So one of your recommendation is that the spectrum should be located. Although TRAI has recommended kind of spectrum for private 5G network, there are various modes they have talked about. 4 or 5 options they have given, but new dimension is that for critical infrastructure, identifying the critical infrastructure of country and allocating a spectrum is a new dimension which you talked about. So your points are very genuine and important, and perhaps from our side we will send this to those responsible in policy making here at DOT so that they can discuss and come out with solutions. And there is chat box also, there is a lot of questions coming and people are also answering. So it's a very good discussion going on in the chat box. So similar to other speakers, I would request that participants please write your questions for Amarjeet ji in the chat box, and I would request Amarjit sir to kindly answer whatever question comes on the chat box. Thank you so much, and let me proceed next in the session. So now I'll be inviting Kumud Wadhwaji. Kumud Wadhwaji, may I request you to kindly open your mic and video. Thank you so much, Amarjit ji. Yeah.
Thank
Kumud,
you very much.
Yeah, thank you. Bye. Kumud, are you around? I see that Kumud, let me see if Kumud is there in the attendee. Okay. Kumud Vado on behalf of Arun Kumar Mr. May I request that can you raise your hand so that I make you presenter?
Now I got the rights. Earlier rights were not there. I'll just share. Am I audible?
Yeah, you are audible. Yeah,
Okay.
so thank you so much. Now you can see you, ma'am. Kumudji is from National Power Grid Mission. For our participants, you may be knowing that this National Power Grid Mission was established way back in 2015 to accelerate smart grid development in India, and a lot of activities are going on at NPGM. And we have Kumudji who would be telling us about various important projects and technology being used. So over to you, Kumudji.
Thank you, Ashokji. Good morning, everybody. And first of all, I would like to thank organizers for giving me an opportunity to share what is happening in power sector, what disruptions are taking place. Let me share my screen and then talk about.
Yeah, we can see your screen. You can go to full slide mode.
Is it okay now?
Yeah, it's coming. Please go ahead, ma'am.
So we heard various speakers talk about the 5G use cases for power sector and how the 5G can facilitate the creation of an energy network. So I'll be talking basically from the other side, wherein I'll be talking about how disruptive technologies in power grid or power sector are making the grid smarter. So what is smart grid? Maybe many of you already know that smart grid is about optimizing energy efficiency and supporting clean energy deployment by facilitating flow of energy and information, both ways between the supplier and the consumer in real time by implementing information and communication technology onto the power network. The smart grid is connecting the complete power sector value chain from generation to transmission to distribution to consumption to markets and consumers. And let me say that consumers are now also becoming generators because they have rooftop deployments, rooftop solar deployments, and they are also injecting into the grids. And now they are becoming prosumers. So all this can be further improvised if we have smarter technologies. And smarter technologies is not just one technology. It is a constant journey when we say that we are to transform our grid to smart grid. If we see the adoption of IT and communication technology started way back with the announcement of APDRP and RAPDRP schemes by Government of India, wherein IT implementation was supported by funding from government side. And therein the processes started becoming automated and we have limited communication available for domain specific solutions. Now if we see the current trend is that we are promoting inter-domain connection by further having widespread communication, which will be discussed in how the solutions are evolving, that we will see in the next slides. Why do we need smarter grids? Because we have to support clean energy deployment, and we all know that renewable, if we are to integrate into the grid, those are intermittent and unpredictable. And for grid balancing, we need to have flexibility for the system. Flexibility is required for power, Flexibility may be required for energies. Flexibility is also required for transfer capacity, and flexibility is also for voltage management. If we map that flexibility requirement in time and space, we will find that for grid stability and ramping requirements, the flexibility needs are at sub-second level and at the system level. When power quality management is at second level, regional and local level, then we have solutions for demand response, wherein consumer is participating for supporting the grid. And for that, we also need minute or hourly basis flexibility solutions for voltage management and for transfer capacity, congestion management. Flexibility for energy will be required in the longer term, wherein we have seasonal load variations. To support that, we may have to have solutions like battery storage or other forms of storage for promoting renewable integration. And also we can have a power purchase portfolio management for flexibility solutions. So what are the solutions that can be there for supporting the flexibility or smarter grids? We have better forecasting with widespread instrumentation and advanced computer models that allow system operators to better predict and manage the renewable energy variability. We have smarter inverters that can provide control to system operators as well as automatically provide some level of grid support. Then we have solutions for demand response, wherein smart meters coupled with intelligent devices and even some interruptible loads, as we heard earlier speakers. They allow demand side contributions for system balancing. Storage can help smooth short-term variations in renewable energy output as well as manage the mismatches in supply and demand. And also on the larger scale, we need to have real-time system awareness, wherein sensors like PMU allow system operators to have real-time awareness of system conditions to actively manage the grid behavior. So one of the core components for, say, smarter grids is in the distribution sector is advanced metering infrastructure. Advanced metering infrastructure is having a smart meter which also has connect and disconnect switches and two-way communication capability to support measurement of instantaneous power, energy consumption, reactive power, and it also helps detection of over-under voltage, high-low power factor, current imbalance, low overloading, underloading, and tampers if at all they are in the system. This smart meter is to communicate to the control center, and the communications can be categorized into home area network, wherein communication is between the building's interior or load to the smart meter. The field area network, wherein the smart meters need to connect to the data concentrator unit, and wide area network, wherein a high bandwidth backhaul communication link is required between the data concentrator and the utility. Then metadata acquisition system and head-end systems are there in the data center, which acquires data from the meter even on demand and at selectable periodicity. They also control the load and give pricing signal. Then we have to have audit trail and maintain the time synchronization with data concentrator unit. Metadata management system again is a database tool with advanced analytical tools that helps to interact with other information systems, that is the consumer information system, outage management system, the other business applications like ERP and mobile workforce. It supports storage, archiving, retrieval, analysis of metadata. It also has the function of validation, editing, and estimation to ensure data validity. A pictorial depiction of AMI architecture shows that we have these smart meters at various residences, and the communication between building's interior and the smart meter is what is in the home area network. Then we may have GPRS or 3G or 4, as of now 3G, 4G network, which is now maybe getting upgraded to 5G kind of scenario as and when it is available. Then RF communication for connecting to the data concentrator units. And then there are also smart meters at feeder and DTs. So there will be a neighborhood area network, which will be communication between the data concentrator to the smart meter, which is again connecting to the data center. So different this networks, home area network will require different kind of technology deployments. This neighborhood area network will have different technology requirements, and this say wide area network will have a different technology required. So these are the categories of various communication requirements for AMI. Next, we see when we see the policy for electric vehicles is now announced, wherein we have 30% of vehicles to be electric vehicles by 2030, as announced by Government of India. And if these electric vehicles are in the grid, the apprehension is that everybody will get back from work in the evening and then try to plug in their vehicles for charging. And the charging current for Tesla may vary from 120 kilowatt to 15 kilowatt, depending on whether we have to go for fast charging, which is, let's say, about 30 minutes charging time to 8 hours charging time. So such wide variation of load and maybe multiple users plugging in their vehicle in the same time, which is again the peak time of evening for the grid, may pose further challenges for the distribution company, because it will add to the peak load and also increase the losses which are already very high in the current distribution grid. So how other utilities are solving these challenges? They are going for smart electric vehicle charging. Smart electric vehicle charging allows scheduling of the chargers for various say time zones. Maybe user can spread the or delay the charging of their vehicle in the later hours when peak load is not that high. So that is how we need to go for smart electric vehicle charging, even for Indian scenarios. Then we discussed briefly about smart inverters. As the country is to support around 100 gigawatt of solar rooftop deployments by in the next few years, so higher penetration of this solar rooftop will pose some challenges for the distribution grid in terms of quality of power supply, in terms of voltage management. Maybe when the pockets with high penetration of solar rooftop are there, the voltages can rise as high as to 65 to 270 volts, which is not desirable for the equipment health and also from safety perspective. So can there be some initiative from the distribution company side wherein we can manage the voltage which is there at consumer premises? For that, globally, the inverters are becoming smarter. As per the latest IEEE 1547 standard, it is now mandated in US, various US utilities and other Australian utilities to go for smart inverters. Smart inverter is that inverter which can autonomously contribute to grid support during deviations from normal operating voltage and frequency conditions by providing dynamic, reactive, and real power support, voltage and frequency right through ramp rate controls. And it also needs to have some communication system with the ability to accept that external command from the electrical utility or distribution company. Next, we talked about, or we heard about consumer participation and consumer becoming prosumer. But consumer can also give support for grid management by participating in demand response programs. What is this demand response programs? This is so incentivizing the consumer for changing their level of consumption in the short term in response to some signals from the utility for taking that action. Why we need demand response? Because generation mix is changing, it is becoming cleaner and more variable. The grid is becoming bidirectional, and we have prosumers in the grid now. What can be various scenarios for demand response? Because if we categorize various scenarios for demand response, then we will get to know what should be the latency or what is the requirement expected from the communication system to support those kind of demand response scenarios. We may require demand response for peak load management. Peak load management because some of us may know that peak load is there for only few hours in the year. And utility is to create a huge infrastructure for supporting that peak load, because now it is mandatory to serve the consumer. And if the consumer is not served, then the regulators are also suggesting that some compensation is to be paid to the consumer if there is no supply at the consumer premises beyond 30 minutes or the no time notified by the regulator. So whether the utility should consider deploying additional infrastructure or additional transformers in the grid to support that kind of peak load, or can we think of demand response solutions wherein consumer is given some signal for shifting their load to off-peak period. So it will be only few day ahead events of few hours in the year for all consumers. We also need to have demand response for promoting this distributed energy resources, wherein and voltage support, because intermittently there may be some variation for the renewable energy injection in the grid. So if that intermittent variation is somehow clubbed with demand response by having some aggregators in the system, then they can give signal to the consumers to say shift their demand so that the intermittency of such solution, such challenges are addressed in short-term basis. We need to have demand response for EV charging infrastructure support. Why would customers shift the charging time beyond their convenient charging time? If there is some time slot based rate for the charging infrastructure, then they will definitely be having some incentive for shifting their charging to a lower time slot, lower price based time slot. And such tariffs are already there announced by the utilities in USA. California has various time of day tariff schemes wherein there is separate tariff announced for EV charging also, because they allow different rate if electric vehicle charging is done in the off-peak period. We need to have demand response for minimizing or optimizing power purchase cost, because utilities maybe which have higher penetration of renewable like Tamil Nadu and all, they are paying huge penalties in the terms of deviation settlement mechanism, because they are not able to schedule their requirement in an optimal manner. So if they can somehow club their scheduling with demand response solutions, so they may have avoided their penalties for deviation settlement. The demand response may be required for congestion management. Maybe there are some areas which are overloaded, some transformers which are getting overloaded, so that area can give signals to the consumers to shift their load so that the overload can be managed. Grid stability, we all know that recently the ancillary regulations have been announced, and those ancillary services require faster ramp rate solutions for managing the grid stability. So we may have in near future some aggregators in the system which give this signal to the consumers for, and that should be a very fast mechanism, or it can be even direct load control by the aggregators for giving support to the grid by giving ancillary services support. How we can have this demand response into three categories. The base of the pyramid will be helping all the consumers understand their energy usage with no price and no device, which gives an insight like Ppt Mode from IIT Hyderabad has shown in detail what is the consumption pattern of various zones in their campus. So for controlling any system, first we need to measure. So once the measurement is shared with the consumer, maybe they will have to, they will take better actions to control their consumption or to shift their consumption. So we can have that as the baseline of the pyramid. And next on the top of pyramid will be having some time varying rates and enrollment in load control program, so that utilities can approach consumers as and when they need, depending on their system conditions. Next level and the topmost level will be promoting total energy management automation, wherein we need to transform the residential behavior and homes into reliable grid resources. Maybe in near future, each home can be a mini microgrid in itself, which has a rooftop deployed, it has electric vehicle, battery storage, and they all are being managed in an optimal manner, which source is to be used for injecting back into the grid, or which source is to be used for in-house consumption. So that all is programmable for ultimate optimization. So that kind of level we are to achieve. Type of demand response programs will be direct load control program, curtailable load programs, or price-based programs, wherein we have different tariffs in the form of time of use tariffs, real-time pricing, variable peak pricing, critical peak pricing as well. So if we have this direct load control program or controllable load program, because we have some pilots done wherein the temperature setting of the air conditioners at the residence or in the institution are controlled by the agency to manage the consumption during that time. So that is also happening for supporting grid as demand response program. Direct load control is something which will require communication service reliability to be of utmost level. And on transmission side, we already have phasor measurement units deployed which transmit the data at sub-second level. We have about one packet after every 40 millisecond as of now, which is capturing the state of the system in terms of voltage, current, power, and phase angle. And that is being transmitted to the control center for better state estimation and taking the corrective actions as and when required. This is part of the Unified Real-Time Dynamic State Measurement Scheme, which is covering about 400 plus phasor measurement units at 358 substations, and its integration with 32 control centers. And this wide area measurement system is helping the transmission system operators to better manage the grid so that there is no grid disturbance in the country. And as we find that renewable integration will happen at distributed grid level as well, we may find that there will be a requirement of distribution phasor measurement units as well, which will be sending data at a very fast rate to the control center for protection of the system as well as for quality of supply management as well as for the taking other corrective actions as required. So distribution phasor measurement units is also being talked about. 5G use cases we have already seen, as Ericsson person has already described how the 5G can facilitate managing the electricity network in a better manner by having this real-time drone-based surveillance, which can also facilitate predictive maintenance with adoption of this artificial intelligence and machine learning solutions for detecting whether there are any hotspots along the transmission line or distribution line, whether there are some loose connections, some members are missing from that leg of tower, or some insulators have chipping. All such things can be detected in real time through this drone-based surveillance that can facilitate predictive maintenance. Because there are some difficult terrains also where these transmission lines are traversing. So those areas can be easily covered by this drone-based surveillance. We can have this 5G for augmented reality, virtual reality, mixed reality solutions for helping field workforces for better restoration. Already it is discussed that we can have the expert consultation to this 5G enabled solutions for remotely supporting the maintenance of the systems, and also for meter reading and equipment fault diagnosis. So this is about the current technology disruptions that are happening in the power sector, and this is being handled by National Smart Grid Mission, which is an interministerial body headed by Governing Council, chaired by Minister of Power himself, that was constituted in 2015, and we are supporting this National Smart Grid Mission as part of National Smart Grid Mission Project Management Unit at Power Grid. We have a small team led by Director and PMU. Various documents are released from this National Smart Grid Mission, which are available on our various on the website for smart meter deployment. Also, we are collaborating with the TEC and TSDSI for the technical report that they are preparing. Already they have released this IoT ICT standards for smart cities, which is prepared by TEC, that also covers the AMI and other smart grid use cases. We are also engaged and actively contributing for IoT and 5G applications in smart grid, which is under preparation by TEC. Recently, government announced this revamped distribution sector scheme, and in that around 3 lakh crore is there for deploying smart meters around 250 million prepaid smart meters, and for system augmentation for loss reduction. The objectives are to reduce the losses to 12 to 15% level by 24-25, and also to reduce the average cost of supply and average revenue realized gap to zero by 24-25. Also, we are to develop the institutional capabilities for modern or smarter distribution companies. There is a thrust on improvement in the quality, reliability, and affordability of power supply to consumers through financially sustainable and operationally efficient distribution sector. So this, of this 3 lakh crore, which is to be given for as part of demand distribution sector scheme, already 50% of the projects are sanctioned, and that was announced very recently. If 250 billion smart meters are to be added in the grid, so we need to have a very reliable communication service provider, and we, as utility, we need to make an assessment whether we should outsource the communication as it's being done by the deployments which are there from Energy Efficiency Services Limited, or we have captive communication service providers, like the case for Indore, wherein we have around 1 lakh plus meters on RF technology, which is again a captive solution. For that, the assessment should be based on whether we are to go for time critical usage of the communication network. We need to have the optimal network configuration for metering, SCADA protection, and also peer-to-peer trading, because already a pilot is done for blockchain-based peer-to-peer trading at UP Power Corporation Limited. So those peer-to-peer trading functions will be required in very near term, when all the distributed energy resources would like to optimize their revenue by trading or by getting open access to the system. So for that also reliable communication services will be required, and balancing and supporting the local microgrids. Our experience so far has been that reliability for data is not reaching around 100%. It is around 80%, depending on the location of installation and the signal strength. In suburban and urban environments, the reliability is fluctuating because maybe some network tuning is not properly done. And if there are some, if there is a network where frequent outages are there, frequent power interruptions are there, the network load per radio cell will be higher, because as the power comes back, so multiple nodes, multiple smart meters will try to push their data instantaneously. So where the outages of the power network are higher, the load per radio cell will be higher. Where basically data which is being reported from smart meter to high-end system is categorized into daily profile and load profile, which is once in 24 hours generally, and in off-peak hours of around 10 to 15 kilobyte data size. But if the customer is to participate in the demand response program, then we should have that facility to transmit the data for every 15 or 30 minute log, wherein the data volume will be around 1 kilobyte. For billing profile, once in a month the data is to be transmitted, and for remote connection and disconnection, where the data volume is around 5 kilobyte. But we need to have very reliable solutions of communication services for this demand to take place. Current communication rate is around 90 to 92% for daily reads due to fluctuation of radio signals at different time intervals. As the signal strength varies, the coverage is not good. And real-time communication for connection and disconnection is getting paid for 6 to 8% of the meters, because government has announced that we need to have prepaid smart metering, and if prepaid smart metering is there, as and when the meter is to be recharged for further amount of for consumption of power, that time the disconnection should happen at a very in a very reliable manner. And once the payment is made by the consumer, again the connection is to happen at a faster pace. If there is a failure for connection and disconnection, that is not going to support the prepaid metering, because it will impact the utilities revenue as well as customer inconvenience will be there if we are not delivering the reconnection as expected. We need to have the power system testing facilities because individually the components are tested. Meters are getting tested at various test centers, maybe. Then we are also having the communication chip testing as per the standard. But are we testing that in some kind of, test bed wherein complete power system emulation is happening so as to gather if there are some challenges because of, say, receiver signal, because of some, say, vehicle which is coming in the line of sight, and maybe there will be some other challenges also which are there on field but are not there when we individually test the components. So system testing approach is to be adopted, and we are to prepare the relevant use cases for system testing so that we can have the near deployment scenario emulation happening on the lab scale, and then testing can take place for that. Major challenge that we are facing is interoperability challenge. We need to have some innovation happening around that interoperability solutions, and maybe 5G can support this interoperability in a better manner. That is what we envisage from 5G services. As of now, meters from screen manufacturer are only interoperable, and they have to establish their RF mesh in the current deployments, or even for the GPRS based solutions which are there from the ESL side, there were various challenges that were faced for getting the data in the meter data management system. There are presently no standards for data concentrator unit gateway devices that also is to be prepared. So this is again depiction of the interoperability challenges, wherein we find that this is the meter to head-in system is there in the silo manner, but once there is vendor A and vendor B in the system, so the meter is not able to communicate to the ECU of the vendor B. Similarly, if there is there are some meters from PLC vendor, again they are not able to communicate to the other vendors from GPRS vendors C and D. So we need, when the expansion of smart grid or expansion of smart metering is to take place, so either we need to get the solutions from the same vendor, which is a vendor lock-in situation, which is not allowed as per the current contracting mechanisms, or we need to get another data concentrator unit and maybe sometimes head-end unit, which can be from which will be from the same vendor who is supplying the meters. So those things are to be addressed if we are to go for such large deployment of smart metering. We need to have interoperable solutions. For IT systems, already interoperability is there. We can get the, if we take the example of email, the email is available from the desktop to mobile phone to laptop, and that mobile is using GPS communication, maybe laptop is on Wi-Fi communication and desktop is on the LAN. So there is an interoperability. Data packet or email is getting transmitted to all the devices irrespective of the communication channel that is being used by that device. So why not we can have that kind of interoperability for the our AMI systems as well, wherein irrespective of the communication channel, we should get the data from the meters to the metadata management system and head-end systems. Also, because we find that the performance of this SIM card or the telecom service provider is not uniform at all locations. At different locations, maybe we need to have different communication solutions. So can we have a plug and play kind of solution wherein we can just put in the next chip, which is on PLC or other such technology, which is serving the consumer better in that area. So plug and play kind of support for communication, if it can be facilitated. maybe there is a common connector, like we have a connector for USB to micro USB, USB to USB Type C, and USB to Lightning charger. Similar such connector can be there for communication as well from the intelligent devices. So that's all from my side, and I think I complete in time. If there are any questions, yes. Any questions?
Thank you, Kumud Vadavaji, for again a wonderful presentation and a lot of points you brought in while presenting. One of the important issue which you brought in about two-way communication between grid and the utilities, wherein you gave an example of EV, electrical vehicle charging, that if grid can tell the vehicle that when to charge, when there is a less load on the grid, EV can charge. Similarly, you give an example of smart inverters wherein they can support the grid in case grid are kind of getting overloaded by reverse feeding the power, and also the charging of those inverter can take place at a time when the grid load is less, and that is possible only when the two are kind of two-way communication is happening between the two. You also talked about various schemes which NSGM is running, and a lot of capex are being infused. That will definitely help our country go in a smarter way or smart grid. You very interesting topic you brought in about interoperability, and you gave an example of email, that if I have a Gmail, I can write the email to any Yahoo Mail or any other email the because of the interoperability between the various email server. You don't need not worry that where the other address is. Whereas if you use WhatsApp, unless you have WhatsApp, you cannot send a message to another WhatsApp user. So there is interoperability issue there. So why not have interoperability of this communication equipment, just like email you talked about? So very nice, and perhaps since standards are evolving and kind of integrating like 5G, so that kind of interoperability may come in future. So thank you so much for such an insightful presentation, and also giving requirement to the standard bodies that how interoperability and also work upon. You also talked about certain physical interfaces about USB and all. So thank you so much, and I would request my all the participants to ask any question in the chat box, and would request Kumudji to kindly answer in the chat box itself. So thank you so much, Kiran Vadvaji. So now may I invite our speaker, Sanjeev Rana ji. There is a raise hand by Bindu. Okay, I can take. Let me enable your mic. Bindu ji, if you are wanting to speak, I'm just enabling you. Yeah, now please go ahead if you have any question.
No, actually, Mr. Ashok Kumar ji, I pressed the raise hand button by mistake. I was looking for the chat option. I'm very sorry for disturbing the webinar.
Okay, no issue. Thank you so much. And Sanjeev Rana ji, are you around? Can you open your video? Sanjeev ji, can you hear us? I see you in the as presenter. Sanjeev Rana ji.
Sir, can you assign right? Yeah, can you assign rights?
I have already given right. You can open your.
Sir, please assign right to Rashmi.
Rasmi, okay. So Rasmi, you are also a presenter. So please go ahead.
Okay, thank you, sir. Thank you.
We can see your screen. It's not fully coming.
Is it visible?
Yeah, I think it's not, I mean, it's a green screen which is coming. So can you reconnect your,
Yeah.
just unshare and share it again, sir? Yeah, we can see. We can see. Yes. Now, please go ahead.
Yeah, good afternoon, sir, and thank you very much for providing me such a great platform. I'm Sanjeev Rana, and I'm heading the communication networks in Tata Power Delhi. And we in Tata Power, we are distributing power not only in Delhi, but also in Mumbai, entire state of Orissa, and Ajmer. We are also like a consultant to many of the utilities in India and outside India. So I will be sharing my experiences and the issues we are facing as a communication engineer in power sector. So if you see the key challenges in Indian power sector, I think there is a bit delay.
Yeah, maybe because of bandwidth issue. Yeah.
Yes. Yeah. So I think now my slide is visible. So if you see the key challenges in Indian power distribution utilities, first is on the performance side. There the utilities are struggling with high AT&C losses. Losses are as high as 30%. And then low billing efficiency as low as almost 65% to 85%, 90%. Then high provisional billing rates up to 15%. Low asset utilization. And there is no mechanism of monitoring of reliability indices IDSF in real time. So these are some of the performance challenges though distribution utilities are facing. On the process side, on the commercial side, if I say, then there is no proper consumer indexing. Consumer indexing is there, but on the real time basis, when I'm saying I'm discussing on the any of the issues that is on real time basis. Then connect disconnect is a big issue without smart meters. Then on the technology side of it, there is low utilization of implemented technologies. If we benchmark ourselves or our utilities in India with the global utilities, then we found that yes, we have implemented the technologies, but the use cases, the utilization, that has been very low as compared to other utilities across the globe. Then there is a challenge of unstructured technology adoption. Many of the utilities like they do not have like a technology roadmap. And if there is a technology roadmap, then it has to be properly aligned with the power sector. Because in power sector distribution, the OEMs are driving the need for technology adoptions. And another challenge we are facing in power distribution, like I have been with Tata Power for last 17 years, and most of the times I have been in the my primary job has been the evaluation of technologies for deployment in power sector. So what we see is the technology life cycle. That is another challenge. So these are the different challenges which the distribution utilities are facing. And mitigation of these challenges, whether it is on the performance, process, people, technology, that can be overcome by deployment of the smart technologies. Now, if you see, this is the communication architecture for distribution utility. If you see, we have the grid substations, 66 by 33 kV grid substations, 11 kV distribution substations, and down the line we have the distribution transformers, ACB, distribution boxes, and the consumer end. So if you see on the main side, on the WAN side, we have the control command and control centers. We have the data centers if it's not on cloud. And these control centers or the data centers, they are connected through the utility WAN. Then there is a area called field area network where we have the distribution automation. We have the ring main for passage equipments. We have auto reclosers and sectionalizers. Then we have these APFCRs, power factor calcium relays, the multiple applications on the area network with a strong communication system. Then on the user side, we have the home area automation. Then we have this distributed generation. Then are coming like electric vehicles. And then we have access to the external world. Earlier, it was within the boundaries of the grid substation, the power distribution. Now it has come to the consumer side. So we need to provide access to our systems in real-time basis to our consumers. So 2-3 factors which come into effect: strong, reliable, and a very secure communication infrastructure for our home area applications, for our field area applications, or where our main applications for command and control centers and the data centers. So this is how we have distributed the different requirements or different segments of the power distribution. Now, what are the key objectives? Key objectives of smart grid. Like I have already discussed the challenges in process or technology or people or performance. They can be like we need to deploy the smart grids to overcome those challenges. And accordingly, the key objectives of these smart grids are like on the consumer side, the first one is the customer affection or customer delightment, or you can say the customer empowerment, then sustainable energy, then reliability and safety, and of course the cost efficiency. So these are the 4-5 drivers. And for that, you need smart customers, smart technologies, smart business partners. But there are certain limitations, which are the legacy with the legacy systems. That is interoperability challenges there, scalability challenges there, and vendor lock-in and obsolescence challenges are there. Okay. Then these are the various smart grid technologies and how they are how they are related with the key objectives of the smart utilities. If you see, there are a foundational infrastructure. That is, for any smart utility, you need to have a very reliable communication infrastructure. If you say under smart scenarios, smart grid, smart cities, the communication is the nervous system. So you need to have a very reliable, secure, and scalable communication infrastructure along with other technologies. Like you need to have a very strong GIS system. And there are various fundamental applications. Like if you see the advanced metering infrastructure, and the tick mark shows the impact of advanced metering infrastructure on the reliability, power quality, safety, efficiency, customer empowerment, and operational efficiency. So this is how we have identified different applications and their impact on the key objectives of smart grid. Okay, so accordingly, we have this AMI system, meter data management system, then distribution automation, then SCADA, then other applications like field for applications or mobile workforce management. So these are the foundational applications. First is we have this foundational infrastructure, which is a very strong and reliable communication system as well as a very strong and reliable GIS system and tightly coupled with our enterprise integration. And we have these fundamental applications. If you see fundamental applications, we have the advanced distribution management system, then we have the AMI systems, and then we have the field force automation system. And over the top of this, we have certain enabled applications. Enabled applications, this is the pleasure, like port location isolation and service restoration. Like they have the impact on the reliability. They pleasure application, it has a huge impact on the reliability and power quality and the operational efficiency. Like if we see some of our circuits, some of our transformers, some of our tie lines, they are like overloaded. And if you find that it has tripped because of the overloading, and we are finding that yes, there is a margin of like we can transfer load from one tie line to another tie line or one transformer to another transformer, so that these applications need a real-time availability of the communication. Then we have this World War optimization, of course, like in cities in Delhi, it is not like we do not have so large feeders. Then this integration of distributed generation, integration of energy storage, plug-in vehicle integration, demand response home area integration, and microgrids. So these are the different applications which are impacting various like pillars of the smart grid. And for all these applications, we need a strong communication infrastructure. Accordingly, I think there is a delay, sir, so please excuse me.
Yeah, yeah, I can go ahead. We are able to see your
Yeah,
slide.
Yeah. Okay. Yeah. So these are the different applications like distribution management system, AMI, network automation and protection, integrated security solutions. Like two things I have missed, like one is the protection of the actually July 2012, I believe, when there was a cascade was out. So there we felt the requirement of islanding and protection of our even our sub-transmission systems. So we have a different kind of protection like distance and for difference protection very low latency less than 18 millisecond or 15 millisecond. So you need to have a very reliable communication system with very low latency for this relays to operate. So there is a use case for product communication. Another is security solutions. Now, since these grid substations, they are like at far locations, remote locations, 100% of our grid substations, they are now automated. They are remotely controlled from the control center. So we need to have physical security. So we have deployed these integrated security solutions where we are monitoring these grids on real-time basis. So there we need a huge bandwidth. And then this distributed in a solar and electric vehicles, these are coming up. So we need to have, we need to integrate them with our main system. So these are low latency, high bandwidth and high availability. And based on that, these are the key requirements for any smart application to sustain. And for that, I think 5G is the enabler. If we discuss, if I share my experience in Tata Power, like we have deployed many technologies, 17 years. So most of the technologies which we are able to sustain or which we are able to like get at least 70% utilization is we are having own communication network. And we have struggled over the period of time where we have like we are using the public network from the telecom service providers. So I think after this deployment of 5G, there are different models I will be discussing in my subsequent slides. So these like key requirements of this smart technology deployment will be met by 5G. And if I discuss the different applications which have been deployed in our network in Tata Power Valley. Yeah. Are you seeing the same slide? It's a different slide, sir.
Slide which we are seeing is the communication requirement for smart utilities, where you have given 5G enablers.
Okay, next slide. Yeah. Next slide is coming. I'm so sorry for the delay.
Maybe from Rasmiji side, there's a bandwidth issue. Not getting.
Yes.
Yeah.
Yes. Okay.
Yeah. Now the next slide has come.
Yeah. Yes. These are the different applications and services which are running in Tata Power Delhi distribution network. If I see the first service is the teleprotection, it is like line difference relay protection, and it's a point-to-point service. And if you see the attributes, it needs a very low latency, and the bandwidth is of course low, but it need to be highly reliable. It need to be there all the time. So another application is the call center. Call center, we have multiple call centers, and there the latency required is again very low, and availability is very high because the call center is the face of the utility or the gateway of the utility for the general public. Then we have configured fire alarm services in all our grid substations in all our offices. We have implemented these services. Then we have SCADA. SCADA, we have 94 grid substations. All these grid substations are connected to our central control center. Then another very important service which has been provisioned is ICCP, Inter-Control Communication Protocol. I think this is to this is required for real-time monitoring of if whether we are overdrawing, underdrawing within the specified frequency range. So this is the service which has been our control center has been connected with the detail control center, transmission utility control center. Then we have this enterprise service like email and all that. Then for smart metering, we have implemented two systems. One is mesh, and that is another NBRT system. So we have again defined for them. Then we have our own data centers, and for synchronization between data centers, there is a point-to-point communication connectivity. Then SCADA application, database application. Then for integrated video surveillance or integrated security solutions, we have defined point-to-multi-point service. The idea or the point I am trying to share with you is there are 17 such services which has been defined in Tata Power, which need a communication system with either very low latency or medium latency. Some of the applications require low latency, some of the applications require very high bandwidth, and many of the applications they require very high reliability. And of course, all the services they need a communication system which is highly secure system. So the point I'm trying to share all these things is a requirement of a robust, reliable, secure communication system for power distribution. I'm going to the next slide.
Yeah, it's coming.
This is demand management and consumer empowerment. We have done this project in 2013, automatic demand response through smart metering. That was a pilot project. So in that pilot project, basically what was there, we have implemented one smart metering system, as well as we have identified very high load consumers. We identified their loads as critical and non-critical. And non-critical loads, they were like connected through a demand controller, and it was connected to our control center. And there was a smart metering, which was again connected to the control center. So in real time, whenever there was a power requirement, power crunch, we used to intimate the consumer that yes, there is a power there is a power, huge power demand, and instead of shedding the entire load, we will be shedding your non-critical loads. So that pilot was done in 13. So we have certain experiences or of that pilot project, which I will be sharing. Like there were two parts. One was the RF mesh. RF mesh was used for the smart metering. Another was for the controlling of the non-critical load of the consumer. For that, we use cellular network. One of the key finding of that project was even though my smart metering availability, the communication reliability of the smart metering RF mesh system was approximately 95%, but we could not achieve more than 40% with the cellular technologies. We tried from the different operators. So that was one of the learning or the experience we we have taken from that pilot project. And the point I am trying to make here is this is in that project we provided the consumers application to show them their real-time usage, whether their MDI is exceeding or not, whether their if there is any unbalance or any earth leakage, or to give them the visibility of different analytics through smart metering. So and even though in the US and other countries there is a concept of incentivization, that is whoever the consumer who is taking part whenever there is a this power crunch, they are incentivized, and smart metering is used for that purpose, whether the consumer has how much he has contributed in saving the power. So if we have a very strong communication system, we can see on the left side that is the consumer participation. Consumer participation, whether the consumer is active or consumer is passive. Similarly, it depends on the power demand, whether the power demand is elastic or inelastic, and a third one is the risk. So if you see, there are different rates of power, that is the fixed rate, flat rate, time of use, critical peak price, and real-time pricing. So after once this 5G is in place, we have a robust communication infrastructure in place. We will find that our demand is going to be highly elastic, and our consumer is going to be highly active. But for that, we need a very strong communication system. Okay. So next is we have implemented various technologies, and then we try to evaluate different technologies based on our experience. So we have compared different technologies based on the coverage area, the technology life, the battery life, scalability, cost model, and multi-app support. So for us, if you see from the utility point of view, the cost is going to be we need to be very sensitive about the cost, like whether it needs a capex infusion or whether they are opex heavy. So we need to see that, and the application or the communication system we are deploying, whether it supports multiple applications. It should not happen that we are deploying one kind of communication infrastructure for one kind of application, and if there is another communication requirement for another application, the entire setup has to be we need to establish a unified communication system to meet all the utility requirements. So this is how we have compared different technologies based on our experience. And this is the communication network we have built. Like in Tata Power Delhi, so we were having some lines, transmission lines. There we were having some OPGW network. And at the same time, whenever we are laying our power cables, whether 11 kV and higher cables, we do lay optical fiber cable along with the power cable. So when a new grid substation is coming up or any distribution substation is coming up, we are laying a new power circuit. So we are like laying a optical fiber cable. So over the period of time, if you see, we have developed our network, optical fiber network of 400 kilometer in a total area of 500 square kilometer. So, and if you see, it is the entire system is in the ring network. So there is a n minus redundancy for each and every location. So this is how we have built our communication infrastructure. We have used our optical fibers, then OPGW underground OFC, then we have used the aerial OFCs. And to provide redundancy to the optical network, we have laid microwave links, carrier grade microwave links, and strategic locations between the rings, they have been connected through the microwave link. So if there is a breakdown on the media on the both sides, then microwave links are able to take care of the load. So this way we have been able to provide communication reliability of 99.99% in Delhi, and this is not for this is for the consecutive like 7-8 years. So and all our applications, we have 17 applications I have just shared with you. So these 17 applications, they run over this network. Okay. And this is how we have created our backbone network. It is primarily on the optical fiber network. Next is so we were able to sustain all our technologies using this network. But yes, we did we were struggling for the field area network applications. So in 2017, we deployed this RF mesh network from the Landis and Gear. It is in sub-gigahertz range 865 to 867. And it was a unified communication system. So it was like it is supporting the smart metering infrastructure, as well as it is capable of like integrating the distribution automation devices, street light systems. But primarily we are using this network only for smart metering and distribution automation. And the backhaul for these collectors, it has got different components like meters, then the collectors and backhaul to the collectors. So mostly the backhaul to the collectors is through our optical fiber network. And wherever we are facing, we do not have the optical fiber. So we have provided provision backhaul on the 4G. So 2.5 lakh meters are on RF mesh as on date. And as a complementary technology to the RF mesh, we have deployed NB-IoT. So this NB-IoT network is for 1 lakh smart meters. And this is we are using only for the smart metering purpose. And we are using this network as a complementary to the RF mesh network. That is the areas where it is not possible for us to create our own RF mesh network. We use the NB-IoT meters. And we have our homegrown MDM system, and it is then integrated with other IoT systems, whether it is integrated and it is used for integrated with the MDM is integrated with the network planning tools for asset optimizations. And in the beginning, I have shared that there are foundational technologies like communication and GIS. So once this AMI is implemented, we have been able to like make our GIS system. We are able to fine tune our GIS system so that it is highly accurate. And then there are different, it is integrated with different business systems, that is the CRM, ISUs, or the analytic systems. So this was all about Delhi. But Delhi and we are having almost similar infrastructure, kind of an infrastructure in Mumbai also. Only difference is in Delhi, we have more of our network, communication network on the underground fibers, but in Mumbai, we are more of on OPGW network. Rest of the things, rest of the applications, it's almost the similar way. The kind of penetration is almost same. But we are facing challenges in Odisha. Like in Delhi, if I share with you, we have 20 lakh consumers spread across 500 square kilometer. But in Odisha, the situation is completely different. We have only 50 lakh consumers spread across 1.5 lakh square kilometer. Then, since it was like it's a very small area in Delhi, and we were like able to lay our optical fiber network as the distance between our grid substations is 3 to 5 kilometer max. But in Orissa, where it is up to 15 kilometer, 30 kilometers. So laying optical fiber cable is not a solution, and it's not cost of economical also. And because of the demographic conditions, laying optical fiber is a challenge. Another challenge we are facing is the presence of the operators. Presence of the operators, yes, operators are there. They are claiming to be there, whether it is Jio or Airtel. So, but yes, signal strength is signal strength is not, or the availability is not giving the operators to carry out the operations in real time. So because whoever is carrying out a breaker operation, whether it is on or off, he need to have the acknowledgement back. And the communication system should be strong enough or reliable enough to give the timely acknowledgement. If acknowledgement is not there, operator is in dark, he is not going to operate it again. So that is the kind of challenge, and that is where the adoption of the technology comes into picture. So these are the communication challenges we are facing Orissa, and so we are struggling. We are struggling. We have used. We have taken more than 200 MPLS VPN links from different service providers to connect our key locations. Then we are identifying locations like in Bhubaneswar, Cuttack, or the major cities where we are forming small clusters using optical overhead or OFC, but still it's a pain area for us. This is another example of the integrated security solution, which is the need of the hour. But the problem with this is it is bandwidth hungry. If we have our optical fiber network, then yes, we can take care of it. The bandwidth requirement by ISS system in real time. But if we are required to provide internet connectivity or any other mechanism for real-time analytics, it is so costly that we are not able to afford it. Then, so these were the different requirements of the utilities from the communication perspective. So what we are hoping, once this 5G is in place, based on our experience, we would be interesting in creating our own private 5G network or the LTE network. So because if we have the control over the network, or the network is dedicatedly for mission critical services, then only it can succeed. Because we have seen many of the times that the mission critical services cannot run over the public network. So that is one that is one of the wish list of the utility, that if we can create our own private wireless networks, then we are using this free band, whether it is 2.4, 5.8, or 865.867 for our multiple applications. But yes, we do struggle. We do struggle from the reliability point of view, from the noise point of view. So if we can allow, if the utilities can be allocated some spectrum, for their applications. So it will serve our purpose. Then if a third option is like if utility, if the telcos and the utilities and the product owners like companies like Ericsson or Nokia, they can come together and utility, whether it is on a slicing basis or reserving some bandwidth for utilities and spread sharing across India. Like in case of Tata Power, we are in 5, 6 states. So if we have some kind of frequencies or some kind of bandwidth list from the Airtel or the Vodafone or the Geo, and the operators like Ericsson or Nokia, they can provide the services. So that is another use case. So these are 3, 4, 5, 6 models we are looking, and we are requesting the form to guide us once this 5G is deployed. These are some of the snapshots like what is happening across the globe. This I try to find out from the internet, like utilities like in Poland or whether in America, Germany, they are creating their private wireless networks. And once this 5G is in there, since it's in trial phases, we have identified certain use cases which we are interested to carry out with the telcos or with the other service providers or with the companies like Ericsson, Nokia, and the regulatory bodies like yours. So, we have identified a use case like for our grid substations, the services we are running, ADMS, then applications like Fleager. Then another is sub-transmission protection for LDR. I have heard that LDR is not successful through 5G in AEP, but yes, we will be definitely testing this through 5G. Then operational safety is another area where we have seen, actually we have seen many use cases of 5G. That is for somebody from the control center can monitor, can guide, and can check the persons working on the transformers or on the transmission lines, and he can accordingly, this is a real-time example of operational safety based on the real-time feed from the 5G. And the protection requirement, because what is happening over the period of time, the consumers are increasing, consumers and the transmission lines are getting shorter, time margins are reducing, and it is more and more differential relay protection requiring very huge, very low latency. And of course, this introduction of renewables means conversion of radial feeds to the interconnectors, where bidirectional flow of energy and in real time is required. So these are the different use cases that Tata Power Delhi is open to carry out, and we will be testing these use cases once this 5G setup is in place. So what we hope is 5G will act as a backbone for all these applications, and it will provide the way for the smart utilities. Thank you. Thank you, Ashok sir. This was my last slide.
Yeah, thank you, Sanjeev Rana ji, for very, very insightful presentation on various aspects of smart power grid and distribution network, particularly of Tata Power at Delhi, Mumbai, and also the challenges which you shown us, which you are facing in Orissa. And you also talked about various communication technology which you have tried, and you have also listed pro and cons on different parameters, different aspect. And if I see that out of all those things, NB-IoT you have in the last you have rated as one of the better technology which you have used as of now. And you also talked about how the current issues which you are facing 5G can support, and you are looking at various solution providers if they can come together and solve the problem of power sector. So thank you so much, and we will be opening for any question answers. So I request participants that in case you have questions from Sanjeev Rana ji or from any of other speakers. So most of the speakers are still with us. So you can ask your question. And there are some few questions in the chat box also, which I'll read out for Sanjeev ji. I would also like to mention Mr. Ramu TS from Lekha Wireless. He has been part of the participants since beginning, and he has been in fact answering many of the questions being asked by participants, and he also have posed certain solution from his side to Tata team. So may I request Ramuji, in case you are, I have just allowed you to open your mic and all, if you want to say something.
Sure, sir. Thanks, Mr. Ashok Kumar. This is Ramu. I'm founder and director at Leica. So we have two types of technologies which is addressing power grid type of network, primarily the utility companies as well as the distribution part. Most of these networks we are establishing outside India primarily because we don't have a spectrum which is very similar to what has been allocated in US and Canada region, where the spectrum are allocated for providing industrial IoT network. So this set of network is based on IEEE standard, which comes under 802.16. So today it was a very insightful presentation, both from Power Grid Corporation as well as from Tata Power. So I would like to take this opportunity to probably reach out, because we are an Indian company doing the infrastructure development, the radio access network infrastructure development. So we have narrowband IoT solution as well as a network solution which can operate on a narrowband in sub-gigahertz type. So otherwise, yeah, I think it's a very nice presentation. Thank you, sir. Thank you for the opportunity.
Thank you, Ramuji. And I would again request from the participants, you can either raise your hand to ask questions or you can directly write your question in the chat box. I'll read one question. It's a very, very basic question which any of the speaker can perhaps try and answer. That does it really need 5G bandwidth? Most of the services can be fulfilled by 4G bandwidth as well, except for SCADA, as network is fully distributed. So if any of our speaker would like to try.
Sir, I think Ashok Kumarji, you are the best person to answer this question.
Yeah, so okay, so primarily when you talk about 5G, it has got inherent capabilities of enhanced mobile broadband, URLLC and EMBB, and also the concept of network slicing, wherein for a specific quality of service and other requirement of a network, you can create a slice and serve. So whosoever asked this question is right. 4G can also solve the problem to a large extent, but since 5G is being built for that purpose, it will be more and more useful and better. So I think if any other speaker want to add to it, they can go ahead.
Sir, upcoming smart grid applications like real-time integration, real-time visibility, real-time, that is the key, and the number of devices which we are like expecting to be integrated with the grid. So that necessitates the deployment of the 5G.
Right. So I'm not seeing any. Okay, there is a raised hand. Bindu ji has raised the hand. Please go ahead, Bindu ji.
Yeah, thank you, Mr. Ashok Kumarji. I wanted to ask, the topic of this webinar is 5G use cases for power sector, as in, power sector becoming a user to 5G technologies. But if we also look at the power sector now with 100% electrification, the power lines and the towers have reached almost every corner of the country. So can the power sector infrastructure, the towers and all, also be used to implement 5G the reverse way? Yeah, thank you.
Yeah, so Binduji spoke a very right point wherein so wherever there's a power infrastructure, telecom has to reach there, and vice versa we can say. So why not use each other's capability? And I just take 1 minute to just add on to Binduji. So we were talking about how to manage variation in the, load in the power grid. So earlier question was that whether there can be a two-way communication wherein the utilities can stop consuming power or go on a battery backup at a time when grid is kind of overloaded, and so on. So one of the use case with the telecom companies could be, because telecom infrastructure, if you see their infrastructures, the lakhs of base stations they have spread, and every location they have battery and power plant. So that is backup one. If the two network, the power network and communication network, can talk to each other, and whenever there is a overload on the grid, maybe our base station can switch over to battery and power plant mode and save the grid from collapsing. Similarly, whenever there is an extra power requirement to the grid, they can also backfeed some of the battery power from the telecom infrastructure. So there can be many use cases if they can have together. It's a very relevant white paper published by Ericsson on this concept. I would request this to be explored. So thank you, Binduji, for bringing this point. Any more questions? So there is one question from Ramu again, that can so speakers comment on utilization of public network versus private network. If any of our speaker would like to talk about that. Maybe I can request Sunil Kumar sir, if you want to comment on this particular. Yeah.
Yeah, sure. So anyway, private network is key, as many speakers have alluded to today's discussion, for achieving many of the objectives of the 5G, like low latency and high reliability, etc. Private networks are a must, or it's always advisable. Now it comes to the question where a separate spectrum has to be given for the private networks or not. So as a principle, private networks are always technically better to meet the Industry 4.0 and other kind of requirements which are enabled by 5G. There's no doubt on that. Now, as far as spectrum is concerned, whether it has to be exclusively given for the critical information structure like power, or it can be shared with the telco spectrum. So that is a matter of under discussion with the TRI and the DOT. So we can address it that way. Sir, you want to add to that point? Yes,
Yes, this is not a topic to be discussed.
Yes, volume is low, sir.
Are you able to hear?
Your volume is low. We are not able to hear you properly, sir. Maybe you can speak near to the mic, sir.
Yeah, that's a little better.
Is it better?
Yeah.
Yes, sir.
Better, sir.
Okay. But I'm saying that this is not a topic to be discussed in this
yes, sir.
Event, and spectrum is something that is to be decided by DOT. Now there is already a recommendation from the regulator. So the discussion was to, that stage is gone. This was to be done when TRI came out with the consultation paper. That process is over. So now government will take a final call as to whether the spectrum will be given or not to be given, and how it should be priced and so on. Let us close this topic at least for now. Anyway, go ahead with the program.
Sir, actually, one quick clarification. Say, primarily, my question was primarily with respect to from Power Corporation. Do they see any challenge in putting their data on a public network, or should it be a private network? In terms of security related aspects, is there probably irrespective of spectrum allocation, do we see a security challenge putting this data on a public network? Is the question.
So maybe
That's
if
what I was
Sanjeev
trying to tell you, Ramu. Like private networks have got advantages within the 5G because of security, data is localized. So that will anyway come. But as sir was saying, that the spectrum is something which is under regulation. Private network as a technology which has been enabled by the softwareization of the 5G is definitely it is going to come, and it has got security advantages, it has got latency advantages, many such advantages. But implementation, I mean, spectrum side is something which is will be decided later on by government administration.
Fine.
So there are a few more point or question. I'll just read, sir. So one, Mr. Krishna is talking about high cost of ROW. I mean, will it impact use of 5G in power sector? And there is another question which is talking about the SATCOM, whether that can be a solution for emergency kind of communication. I mean, the constellation of low orbit satellite they're talking about. So yes, that would become one of the pillar of communication going forward, I think. And they're asking a question about the roadmap. So as far as 3GPP is concerned, in release 17 and 18, they have already come up with integrating even the, I mean, satellite communication with 5G. So that integration on the standard body is already going on. So yes, that will come in future. So I think there is no more questions, sir. So maybe I can request Sunil sir for a final vote of thanks.
Thank you, Ashok. So we had a very interactive and very informative sessions from various speakers today. So I really thank Professor Kiran Kuchi and Professor Yamula for giving us an overview to start with. So thanks a lot for the IIT Hyderabad team of Professor Kuchi and Professor Yamula. Then we listened to Subrata Mitra from Ericsson. So he also told us extensively about the various solutions which are already in vogue across the world. So it was very informative, and he has also shared a lot of white papers and other documents in the chat box. So all the participants can benefit from that. So thanks a lot, Mitra, for that. And then we also listened to Amarjit Kumar from India Smart Grid Forum. So thanks a lot, Amarjit, for sparing your time at short notice and giving us your time and a lot of information and insight into the various challenges that are being faced, and also the interventions that may be required from the government and the regulators. You gave a snapshot of that as well. Then we had a session from Madam Kumud Wadhwa, so Senior General Manager from National Smart Grid Mission. She also gave a lot of aspects covering how the power sector is, I mean, as well as from a smart grid aspect, what are the various points, and you could give an overview to all the participants. Then we listened to the actual power distributor of the country, Tata Power, Sanjeev Rana and Madam Rashmi Adhikari spared their time and gave an overview of what is actually on the ground in Delhi, Orissa, Mumbai, wherever Tata is the power company. So that was very insightful. All kinds of 17 applications that are already using, which will be further strengthened with the arrival of 5G, and they will be the early adopter of 5G technologies, I'm sure. So, and all the audience also had asked a lot of questions, very involved questions, and made this webinar quite engaging. So thanks a lot for all the participants from DOT, from CDOT, from state governments, industry, academia, and like how Wireless Ramu also deserves specific mention. He has always been associating with us, and today also he was an active participant. Thank you, Ramu, for your presence today in this forum. So thanks everyone, all my colleagues in Hybrid for associating with this and making this webinar a success. And a special thanks to our DG Professor once again for being throughout the seminar and guiding us constantly. So thanks everyone for this session, and have a good day.
Thank you, sir. Thank you so much, sir.
Thank you, everyone. Thank you very much. It was a wonderful event with so many questions being asked from the experts. Thank you very much, everyone.
Thank you, sir. With permission, we are closing the session, sir.
Yeah, please. Thank you.